Hey guys, welcome to this video on AWS by Intellipaat. Now before we begin this session, please subscribe to our channel and hit that bell icon for further notifications. AWS, that's Amazon Web Services, is a comprehensive evolving cloud computing platform provided by Amazon. It includes a mixture of platform services like PaaS and SaaS. AWS services can offer an organization tool such as compute power, database storage, and content delivery services. Now let's start our session. First, we are going to see Introduction to Cloud Computing. Just a quick introduction and what exactly is a cloud computing is. Second, we are going to see the global infrastructure of AWS. Third, we are going to see how do you exactly create an account in AWS. Next, we are going to see all the pricing models that we have in AWS. Next, we are going to see some common terms like ABS, EC2, ECR, and ECS. Sixth, we are going to have AWS Service Management and how it works. Seventh, and the most interesting part, we have hands-on demo. We learn deploying Netflix applications in AWS. Eighth, we are going to have top 15 tech jobs with cloud skills. And finally, we'll wrap up with AWS Interview Questions.
Introduction to the cloud, AWS. What is AWS? What is cloud basically? Let's just go a few years back before this cloud computing. At the time, what we used to have is an on-premise data center. Now, data center is the word I believe most of you are familiar with. So data center is a place where you have to build a large building and you have to buy the resources. What kind of resource? Resource like server, storage, database, network, everything. So building that kind of giant building will take some months or years. And then you have to pay a lot of fee upfront. You have to buy a lot of resources. And then you have to configure those resources. That again requires some expertise skills. You and I cannot jump to a data center and start configuring. That's not possible. So again, requires an expertise skill that takes days and months again to configure. And then you will develop your application and deploy your application. So by the time you start planning to have a data center and when your data center will be ready, it will be years journey. Now in this case, the biggest challenge is how many resources you will buy. For example, guys, if I tell you that we have to build an application like any internet service, internet banking service, where we are going to expecting to have millions of traffic. So can you tell me how many servers will be required? Is there any formula to calculate the number of servers required to handle that millions of traffic? That's not possible because it depends on what kind of request you have, what kind of application you're running, how long it takes to process the request, and what is your hardware configuration, how many cores of CPU, GBs of RAM you have. So it depends on the software and hardware applications. So the question is how many resources you will buy. If you buy too much, then that is a waste of money. And if you buy too few, then your application will fail to perform. So the on-premise infrastructure are not elastic in nature. Now let's see what is cloud. A cloud is a place where a company will build the data center for you. So they have already configured data center and they have already purchased a lot of resources in that. Various configurations of your server, storage, database, networking, and everything they have managed. Now what we do as a customer, we request for the resource what we need. We request for the resource what we need, and the resources are available on demand basis within seconds. So if you want a server right now, you have to request for a server and the server will be available to you within seconds. If you want a storage, 10 GB, 100 GB, thousands of GBs, you have to request and the resource will be allocated to you. And for this, you don't need to do any kind of commitment. You don't need to say that I will be requiring these resources for the next 1 year, 3 years, 10 years. No, you don't need to do any kind of commitment. You will pay for what you will use. So if you use the server for, let's say 2 hours or 4 hours, you only have to pay for that. So I don't need to do commitment and I have to pay only for what I use. So it's a very cost efficient way of designing and managing an infrastructure on the cloud. And AWS is one such vendor who brings all the infrastructure for you, where you can request for resources on demand, no need to do any kind of commitment, and they are available in seconds. Now guys, here I have a question. As a customer, I can see like there is a lot of benefit. I don't need to pay any kind of upfront. I don't need to do any kind of investment, and I get charged for what I use. But the company which is providing us the cloud services, they have to create the infrastructure. They have to maintain the infrastructure. They have to buy all the things. So when you are not using their services, how the companies will still get benefit? So basically, when you have an on-premise infrastructure, your data center, that is dedicated to you. Only you will have access to that infrastructure, and it is completely for you. But here on the cloud, the infrastructure is shared. So for example, let's say this is the AWS giant data center. Now you have requested for a server. So server is allocated to you. Another customer will come, it will be allocated to another capacity. Another customer will come, it will be allocated there. Now, if you say, I don't need the server anymore, AWS will read the server and it will deallocate the space. It will deallocate the space. And if now a new customer comes, it will allocate the space to that customer. So customer may be number 4. So as long as you are using the resource, it will be allocated to the customer 1. Once you don't need, once you terminate, AWS will free up the space. And if another customer comes, it will allocate the space to that person. So basically the resources, the hardwares are shared between the multiple customers. Shared tenancy. This is called as shared tenancy, where your resources are shared between multiple customers. Now, of course, with this, guys, you must have a question. What about the security? Of course, when a customer 1 and customer 2 are on the same hardware, it will be definitely a security question. So any idea how that is handled? So basically, when you are creating a server or any resource, this completely environment is isolated. This environment is completely isolated and it is available to that customer only. Even if there is an AWS account where you have created 2 servers, then even these 2 servers cannot talk to each other. Physically, these 2 servers cannot talk to each other. So that kind of isolation is available. If you want the 2 servers to have intercommunication, when you own both the server, it has to be done over the network. Via the network channel, they will communicate. But physically, though they are allocated to you, it won't be possible. So at the kernel level, at the root level, those environments are completely isolated. So this is a completely secure infrastructure at the hardware level. This is a level 1 at the hardware level. Now, if you think you do not have a compliances to have such kind of infrastructure, then at the application layer, that is at your side, you can do varieties of things to configure your application more secure. So this is at the hardware level where AWS will take care of it. AWS provide the security. Now at the software level, you can do varieties of things. Now there is no one thing or 2 things. There is a lot of things. So what are these different things and how to configure, how to make it secure our infrastructure? That is our course. So that whenever you will be working on the AWS account for your organization, how you can make your application secure, that we are going to discuss here. So what is the number of services or the things that you have to make sure, that we are going to discuss in our course. Okay. So this shared infrastructure is called as cloud. So as we discussed, we can create a server, or we can access to, or we can have any kind of resource on the AWS. So when you're accessing the resource over the internet from your local machine, from your local system, over the internet, that is called as cloud. That your infrastructure is available somewhere else, which is managed by the cloud service provider, and you are accessing that server over the internet. So whether you're sitting on your home, in your office, or you are traveling, so you can connect to your infrastructure at any point of time from anywhere. You can connect to your services, you can connect to your application globally within seconds. All right, so that is cloud. So here you can see in the simplest term, cloud computing is when you use a computer or server which is provided to you by someone else. So now the someone else is nothing but the AWS. AWS is offering you that computer server, and these are accessible from the web-based tool. So you don't need to download anything on your system. You don't need to download anything from your system. You have to just access everything from the browser. So no installation you have to do on your local machine. So the second concept is virtualization. What is virtualization? Virtualization is basically nothing but on a machine, you create a virtual system. So these are nothing but a virtual. These are not the actual server. These are not the actual physical server. This is a physical hardware, but these are not the physical server. These are the virtual server which are created for a customer one. As long as the customer wants, the machine will be available to that customer. If the person deallocates, the machine will be destroyed. So these are called as virtual machine. Now to give you a simple concept of the virtual machine, let's say you have a laptop computer. This is your laptop computer. It has a configuration, let's say a 4-core CPU and 16 GB RAM. Let's say this is your system on which you are running a Windows system. Now on your Windows operating system, what you can do is you can install VMware or VirtualBox. Have you guys heard of this tool? VMware or VirtualBox? So what the VMware or VirtualBox does is, it creates a small environment in your system. You can configure what configuration you want. Let's say I define 1-core CPU and 2 GB RAM. So out of 4-core CPU and 16 GB RAM, it will allocate 1-core CPU and 2 GB RAM to this machine. And you can have your own operating system. Maybe this time Linux or another Windows or whatever you want. So this is not a physical server. This is just a logical partitioning of your infrastructure, of your laptop. This is a logical partitioning, which is available virtually. So similarly, now this is the AWS giant data center, and this is your machine allocated to you. Or what is the configuration you will say? So this is called as virtualization. Now, how AWS does the virtualization, what tool they use, we'll discuss shortly. So virtual computer environments over the internet and intranet is called as cloud computing. That is the concept of virtualization over the internet and internet is called as cloud computing. So what are the advantages? The same what we discussed as a disadvantage of an on-premise. There is no capital expenditure. We don't have to pay anything upfront. So that's the benefit. Everything is charged per second, minute, or hourly basis, and only pay if you use. Now on the AWS platform, you have a lot of services which are charged to you per millisecond, not even second and minute. Even if you use for per millisecond, you will be charged. So that offers you a very cost-efficient solution. Getting a new server will be as easy as clicking some mouse button. Then it provides a very high available solution. Then take a note of this word, high available, because this concept is going to be very, very important. As a solution architect, this is your responsibility to design a high available solution. So just take a note of this point, because this point we are going to discuss in every AWS service, whether it's a server, network, storage, database, anything. We have security at different layers you can apply. I already told you, security at the hardware side, AWS maintain. But the security on the application side, you have a lot of control on that. So we can apply the security at the network, server, storage, database, encryption, decryption, all you can do it here. Now, flexibility and error sharing, these are the two very important again. To understand this concept, let's go back. Let's say you have an on-premise data center where you have purchased a server. The server, let's say, have an i3 core processor with 8 GB RAM. Let's say you have purchased a server with i3 processor and 8 GB RAM. After that, you deploy your application and you run the application. Now, let's say, guys, after 2 months, after 3 months, after some period, you found that the performance what you need is not there with this particular configuration. The performance what you were expecting, you haven't reached with this configuration. So what you will do now? Is it possible to change the hardware overnight? Can you change the hardware configuration overnight? If you want to do it, you have to request to your managers. They will check with the business stakeholders. They will go with the multiple permissions. That will take a lot of time. And then again, you have to buy a new resource. So there will be a cost associated with it. And then the resource will be available to you. But that is not a case on the AWS. That is not a case on AWS. If this is my machine, if I want to upgrade the machine or downgrade the machine, within few clicks, I can do that. Just within few clicks. So this kind of flexibility that you have, at any point of time, you can upgrade your machine from 2-core CPU to 4-core CPU or 1-core CPU. What is the configuration you want to do, you can do. If you have a 10 GB of storage, now you want to scale to 100 GB. Yes, you can do that. Within second, your request will be acceptable. So that kind of flexibility you have, that you can change the configuration of your infrastructure at any point of time, and you can manage your infrastructure easily. And error shield. It not only offers you error shield, it also offers you varieties of shields that protects your infrastructure from various attacks. On infrastructure, you may have a DOS attack, DDoS attack, malicious attack, bad request attack. So AWS to a certain level protects your infrastructure by default. And then it also offers you varieties of special services that you can enable and make it more secure based on your choice. So if I'm running any kind of banking application, any fintech application, then in such case, I may have a compliances to make sure that the security is enabled. So if you have any kind of scenarios, you can enable those services. Otherwise, with the basic configuration, AWS protects your infrastructure by default. So these are a lot of services. These are a lot of features which you automatically get on AWS. Now here is a very great example. Let's say we are running an application, and let's say this application we are running on an on-premise, on your data center. And you can see the traffic on entire week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Now let's say the maximum peak is on the Friday. And to handle this demand, let's say I have purchased 10 servers. This is an example of an on-premise. So let's say to meet this capacity on the Friday, I'm running 10 servers. That means I have to run all the 10 servers all the time. But if you see on Monday, Tuesday, Wednesday, Thursday, Saturday, Sunday, if you keep on running all the 10 servers all the time, it's a waste of money. It's a waste of money. It's a waste of electricity, a lot of things. Also, there might be a scenario where during the night time, between Monday and Tuesday, during the night time, you might have no traffic at all. In that case, running completely 9 to 10 servers is waste of money purely. And that will reduce your profit from your business. Now with the cloud, what you can do, as the resources are available on demand, so you can buy what you want. If on Monday my requirement is just 2 servers, I'll scale up to the 2 servers. I will run only 2 servers. If on Tuesday I need 1 more server, I will add 1 more server. On Wednesday, if I don't need the 3 servers, I can reduce it to the 1 server. Because the resources are available on demand, I'm not doing any kind of commitment that I need 10 servers all the time. So I can scale up and scale down my infrastructure easily. So when there is a traffic, it will automatically create a server. And when the traffic is down, it will automatically decrease the traffic or decrease the number of servers. So AWS offers you one service called as auto scaling. With auto scaling, you can configure that service and it will automatically create a new machine or destroy a machine based on your traffic, based on your demand. But what we need to understand today here is that with this scaling, we can do a lot of cost control. And as your application is getting traffic, as your business is growing, from 1 server to hundreds of thousands of servers, you can easily grow. So when you are working as a solution architect in an organization, this is what expected from you. that how your application will be highly available whenever it is required. When there is a demand, your server should be there. And when there is no demand, reduce the cost by reducing the number of servers. So that is which is expected from you. Now, there are three cloud service models: infrastructure as a service, platform as a service, and software as a service. On the left-hand side, if you see in the picture, there is an on-premise, the very first picture. Now, these are the certain things that you have to configure. So you can see on your on-premise, it is completely your responsibility to do everything. Building a data center, configuring your network, storage, server, virtualization, OS, and everything. So it comes under your responsibility. Now let's jump to the cloud. And the very first model what we have is an infrastructure as a service. In the infrastructure as a service, AWS is responsible to create, configure, and maintain the hardware. That is configure data center, making sure your network, storage, server, virtualization is all the time up and running. Making sure that whatever your servers are required, the number of servers, the number of storage is required to make sure they are available whenever you want. That is the guarantee from the AWS. So till the process of virtualization, AWS takes care of it. Now, what is your responsibility? To install the operating system. So what is the operating system you want? You can choose that. If you want Linux, if you want Windows, you have varieties of options here available. You can choose that what you want. You can have to configure your own database. You have to apply the security what you want and the applications that you want to host. So these are the four things that you take care of it that comes under your responsibility. So that is infrastructure as a service. A very simple example, I want to have a server. So till the virtualization, AWS will take care of it. Now I can say I want a Linux server. So which Linux I can configure. Let's say after that, I want to have a database, MySQL. So I have to install the MySQL database. I can choose what levels of security I want to provide, encryption or network layer security or whatever I want. And then I have to develop and deploy the application. That is infrastructure as a service. The second one is the platform as a service. Now here, the installation of the operating system, database, and the security will be taken care by the cloud. Of course, you can configure your requirement that I need a server of 2-core CPU, 4 GB RAM. I need a Linux machine. I need MySQL database. And these are the security that I want to apply. Of course, you will provide the configuration, but the process of creation, configuration, and management will be taken care by the cloud. Because creating a server is not sufficient. Once your server is up and running, you also need to maintain the server. Time to time patching, update, backup, all the things you have to do. So that part in the platform as a service will be taken care by the cloud. So the configuration, creation, management, maintenance, these are taken care by the AWS cloud. So what you are responsible for? You are responsible to develop your application and deploy the application. And the last one is the software as a service, where everything is done by the cloud, including the application development and deployment. Now, all the three models, infrastructure, platform, and software, are available on AWS. And you can choose what resource you want. If you want to configure a server, you can go with infrastructure as a service. If you want to go with the Lambda, that's a platform as a service. And varieties of software as a service are available. So you can choose the different services with a different platform, with the different models. So your infrastructure will have a combination of all three. And on AWS, there are all three applications available. Let me give an example of software as a service. In the AWS Management Console, you see there are a lot of machine learning service. So for the machine learning service, we have to create an infrastructure. We have to configure the infrastructure, that is server, storage, whatever is required that. And then you have to build that application. For example, Amazon Poly. What Amazon Poly does is, it converts the text into the speech. So if you provide any kind of text, it will convert the text into the speech. A very good example, Amazon Alexa or Echo devices. I'm sure guys all are familiar with Amazon Echo devices. So whenever you hear something from Alexa, you receive that information from Amazon Poly. So that application that does this operation is already developed and deployed on the AWS. So you don't even develop such kind of application that will convert into speech. So this is called a software as a service. So these are the lot of services which are available on AWS. Some of them are IaaS, some of them are PaaS, and some of them are SaaS. Now you don't need to remember which service is IaaS, PaaS, or SaaS, because neither the AWS differentiate between this. Not even AWS differentiate between what is IaaS, PaaS, and SaaS. So you also don't need to worry about that. It's the basics of the cloud. That's why we are discussing. Now let me give you one question. Let's say I have built an infrastructure with IaaS, PaaS, and SaaS. All the three models I have used, different services of AWS. And my application is up and running. And let's say, guys, you are interacting to my application. So which model it will be for you? So that is cloud service model. The second one is cloud deployment model. In that case, we have public cloud, private cloud, and hybrid cloud. Now, what is public cloud? A public cloud is a place where you are on a shared tenancy. So we discussed that what is shared tenancy. On a single hardware, multiple people are going to share the resources. So that kind of shared tenancy offered by the public cloud. So examples are like AWS, Azure, Google, IBM, Bluemix, etc. Now, when you use a public cloud, you have one benefit. The cost is small, the cost is cheaper. Second benefit, you don't need to do any kind of commitment. You have a greater flexibility to choose a resource. And fourth, you get a lot of managed services ready to use. You get a lot of ready to use services. That's the benefit of public cloud. What is private cloud? Basically, I don't know how to maintain a data center, and I don't want to maintain the data center at all. So I approach to a private company, and I will tell that I will require this kind of infrastructure. So that private company will buy all the resources. They will buy the data center. They will buy all the resources, and they will maintain it. And they will maintain it. And those resources will be allocated to you. So you have to pay a larger fee comparatively because that is dedicated to you. You have to do, of course, commitment. And you do not have services like this, like AWS. You will only have a core infrastructure, a server, and a storage managed by network. So you have only this core infrastructure, the infrastructure as a service. On that, whatever you do, you have to create. If you want to run a machine learning or any kind of thing, you have to configure. The security will be handled by the cloud service provider for the infrastructure. And for the application, the customer will be responsible. But here, we have an infrastructure dedicated for us. So that is private cloud, like offered by HP, VMware, Red Hat, etc. And then you have a hybrid cloud. What is hybrid cloud? A hybrid cloud could be a combination of any two network. A hybrid cloud could be a combination of any two network. Maybe you have an infrastructure on AWS as well as infrastructure on Google or Microsoft. So connecting these two infrastructures together could be called as hybrid. So one public to one private can also be called as hybrid, or public service to your on-premise data center can also be called as hybrid. So any two networks which are on two different platforms can be called as hybrid. Now the question is, why someone will go for a hybrid? What is the advantage of hybrid? The first scenario is a company is already having an on-premise infrastructure, but they are very limited. So now they want to scale it on the cloud, on the AWS. So in that case, what they will do, whatever the infrastructure they have, they will run on that. And what if the additional resources are required, they will all go on cloud. So their application is running on both on-premise as well as on the cloud. So it could be one scenario. The second scenario is some company uses cloud as a backup. So they are running everything on their on-premise. And in case if their on-premise fail, they should be running on the cloud. They should be having their application smoothly running on the cloud. So if their on-premise fail, they will fail over to the cloud. So they will replicate all their data, database, everything on the cloud continuously. So that if one goes down, the other can survive. So some company uses it for the backup.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let me give an example. Varieties of banking application, varieties of fintech application, they are not allowed to design the infrastructure in the public. They are not allowed to design or store the user information, customer information on the public cloud. Like banking application, fintech application, healthcare application, etc. So what the companies do is they design the infrastructure on the cloud. All their web servers, all their application servers are available hosted on the cloud. And their database is running on their on-premise. Their database running on their on-premise, which is a compliant. So whenever the request comes, the request will be handled on the cloud where you can easily do the scaling. And this cloud services, when they want to interact with the database, they will go to the on-premise network and they will fetch the data. So this is AWS and this is your on-premise. And having infrastructure on both will be called as hybrid. So maybe you have an on-premise already infrastructure available, maybe use it for the backup, or maybe you have such kind of compliances. In that case, you might require to go with a hybrid. So these are the three deployment models: public, private, and hybrid. We have discussed the benefits and disadvantages of all three. You will have a lot of benefits on the public, cost effective, then flexibility on the resources. You can upgrade and downgrade your machine, no commitment required, and you get a lot of platform and software as a service. On the private, you only have a benefit of having a dedicated infrastructure, which not at all nowadays required, because all these big companies, whether they are fintech application, whether they are banking or any kind of, even the government sectors are moving to the cloud. So having into the public cloud is not a problem anymore, because all the government restrictions that we have is now followed by the public cloud. You will find varieties of compliances report managed by the public cloud vendors. Whether it's a METI, whether it's a SOC 1, 2, 3, PCI DSS, everything is now available with the public cloud. So even governments are considering the public cloud for designing the infrastructure. Now these are just a comparison between the different cloud service provider. So you know who is the leading in the cloud service provider. And of course, the main reason is the number of services what you receive, the cost what we have. And there's still one more concept that we have to discuss that will blow your mind. That is high availability. How you trust an AWS network that whenever you want, the resource will be available to you. So that scenario we'll discuss it shortly. Of course, with that, you must have already done the study. The best part of having a cloud infrastructure is you don't need to spend a lot of money on designing your infrastructure, maintaining your infrastructure. And that gives a benefit to an individual like us to have our own infrastructure on the cloud, or to the startup companies. The hardest part of any startup company is they don't have funds to design the infrastructure where they can host their application or try their idea, because they have to buy the resources. So it's an advantage for a startup companies that they can bring their ideas on the cloud and they can easily execute with a very small capacity. And if the idea works, if they are good to go, they can go live with whatever the scaling they want, from one server to hundreds of thousands of servers. So it gave opportunity to many startup companies to build the infrastructure. And guys, if you just Google a little bit, what are the top startup companies currently in the market and what infrastructure they are using, you'll find they are on the public clouds. They are on the AWS. You can check for the fintech application, banking application. You'll find a lot of services are deployed on the cloud. So it gave a lot of benefits to these companies. So what is AWS? AWS provides an on-demand cloud computing services to business and to the individual, of course, owned by the Amazon.com. It offers you varieties of services, computation, content delivery, database storage, and a lot of other functionalities. Who is a competitor? Of course, Google and the Azure is a competitor. We know that. This is a management console. I'll go through the demo one that will give you more clarity on it. Now, who uses the cloud? Big companies uses the cloud, of course. So this is just an thing. Now, what we need to discuss here is what really important to us. First of all, guys, I have one question. Let's say you are now a solution architect and you are building an infrastructure for your customer. So when you approach to them that and you suggest them that you should move it to the cloud, now how AWS manage? So this is something which is not available in your slide. This is called as AWS Global Infrastructure. What the AWS Global Infrastructure has? It has three things. One, region. Second, availability zone. And third, edge location. These are the three things we have in the AWS Global Infrastructure. So the very first is region. What is region? It's nothing but a geographic location where the AWS data centers are available. It's a geographic location where the actual data centers, physical data centers are available. Okay. So we have a region in India called as Mumbai. In US, we have approximately 4 to 5 regions. North Virginia, California, Oregon, and few others are available. The approximately 25 regions are available globally. And you can choose what kind of region you want to work, where you want to work. So maybe I'm sitting in India, but my customer is located in US. I want to design infrastructure in US. So I can choose the US region and I can deploy the application there. So what is region? It's nothing but a geographic location where the AWS physical data centers are available. And every region has minimum 2 availability zones. Minimum 2 availability zones are there. So what is AZ, availability zone? An availability zone is nothing but a cluster of data centers. A clusters of multiple data centers together become one AZ. And similarly, in one region, there will be multiple AZ. So this is my region, and this is my AZ1A, AZ2, AZ3. So we have to pick a region, and inside the region, there will be multiple AZ. At least 2 AZ will be there. And what is AZ? It's a clusters of data center. Now, each of these AZs are completely isolated. So that if there is a failure in one data center, it will not affect the other two. The other two will still up and running. So they are completely isolated. But they are connected with a low latency network. They are connected with a low latency network. So if you want to do any kind of data sharing from one data center to another data center, that will be super quick. That will be super fast. So all the AZs are completely isolated and they are connected with a low latency network. So let's take an example. I want to create 10 servers. I can create 10 servers here. I can connect with my domain so that whenever the request comes to my domain, all the 10 server will handle the request. But guys, is it possible that an availability zone may go down, maybe due to some natural calamities, some power failure, or due to any reason? It might be possible that an AZ can go down. It is not very continuously, it's very rare, but it can be possible. So let's say the AC where you have created 10 servers is down. Now what will happen? What will happen to your application? So what AWS recommend here is, instead of designing the application in one AZ, you can always go with a multi-AZ, minimum with 2 at least. You should start at least with the 2. So instead of configuring all the 10 servers here, I can configure 5 servers here and another 5 servers here. And then I can connect to my application to both the AZ. So whenever the traffic comes, the traffic will go to both the AZ and all the 10 servers will be running. Now, in case if one of the application goes down, one of the AZ goes down, still there will be another 5 server up and running that will keep accepting my request, that will keep handling my request. But still I have a question. When I need a 10 server, when the traffic is high, when I need 10 server, how can a 5 server only help us to run my application? Load balancer will be definitely required, but load balancer is not going to handle the 10 servers capacity. The capacity will be handled by your servers, not the load balancer. So the service which I told you as earlier, auto scaling. So we can design our infrastructure with auto scaling. And if you say in the auto scaling that I need 10 servers all the time, it will make sure that you have all the time 10 servers up and running. In case if the 5 servers are down in one AZ, it will automatically launch another 5 servers here in another AZ. So auto scaling makes sure that the number of servers that you have requested will be always available with 2 conditions. The one, the number of servers that you need all the time. The another condition is minimum servers. If my traffic is down, I don't need the 10 server, then how much should be my minimum capacity? So I can say 3 server, 4 server, 5 server, whatever it is. So if the traffic is down, it will automatically reduce the number of servers. If the traffic is high, you can define the maximum that it can grow. So 10 we are running, I can have additional 10 more servers. So 20 I can define. So if the traffic increases, it will automatically increase the number of servers. So these are the 3 parameters: desired capacity, minimum capacity, and maximum. Desire means how many servers you want to run all the time. So in case of failure of any server, it will make sure that it will add a new server automatically. So you don't need to worry about, or you don't need to keep on watching that application performance. As soon as AWS will identify that the AZ is down or your server is down, it will automatically spin up the another server. Now guys, with that concept, is it also possible a region may go down? That is, you can also deploy in multi-region strategy. So that is also possible on the AWS. Okay. Now the third one is edge location. Now, before we discuss that point, what is CDN, content delivery network? So let me give a simple example. We watch a movie series on the internet, maybe on your YouTube, Netflix, Amazon Prime, anywhere. Let's say the server of that particular application is hosted in US. The application is hosted in US. And my customer is accessing that application, let's say from India. So when a request comes from India, the request will go to the US and the response will be sent back to the India. Now we know that between these 2 regions, between these 2 geographic locations, there is a huge difference. So probably when we are sending the response, it takes a lot of time, maybe 400 to 500 milliseconds, we are sending the data. So in that case, what problem the customer will face? The latency issue. The data is not delivered at the right time. So the person is facing the performance issue, buffering, and all the different kinds of problems. So generally, this is the place where the servers are running, and this is place for where the request is coming. So to improve this performance, what we do, the data what we have on the server, we cache it.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
To the nearest place to our customer. We cache the data to the nearest place of the customer. Now, whenever the customer makes a request, the request will go to that cache location and the data will be delivered from that cache location to the customer. So all the requests will be always sent to the nearest region or to the nearest cache location, which will not take more than 30 to 40 milliseconds as they are close to each other. So in this way, we are improving the performance and reducing the latency between the request and the response. And if cache doesn't have a data, the cache will fetch a data from the US server. So we are bringing the data closer to our customer. A customer can be situated in any part of the world. A customer can be situated any part of the world. That really doesn't matter in which part your customers are available. This is just an example. So this procedure is called as CDN, Content Delivery Network. We deliver the content which is required to the customer, the data which is very frequently used, like the data from the Netflix or Amazon Prime. Now, once a movie or series is released, that data is not going to change. Once a movie or series is uploaded, the data is not going to change, but the data is going to be requested millions of times across the world. So again and again, if the request is going to the server, it will be a challenge. You will require a lot of servers to handle the capacity, and it will also affect the performance. So in that case, we can use a CDN. So Amazon Prime, the music applications. Then if I talk specifically about the AWS customer, then various of news channels uses this application. News channels have to broadcast their data, and they have large amount of media content, the large amount of read-only content, where they have millions of requests. So they use this service. If you guys have ever played the Angry Bird game or Candy Crush game, that service uses this CloudFront network. HBO, then your Hulu network also designed on the AWS CDN. The mobile update nowadays, what you're receiving from from Apple, from Samsung, MI, and from many other companies is also delivered via the content delivery network. Whenever there is an update, the update is going to remain the same for all the customers. So instead of again and again requesting from the server, the data can be cached and easily delivered. So when you have a data which requires to be distributed among a large amount of user, and the data is not going to change very frequently, in that case, it's a very good service. But there are two challenges here in the system. One, how you will design the CDN, and the second, where you will cache. These are the biggest challenge. And for this, large amount of infrastructure will be required. So what solution we have? To design the CDN, there is an AWS managed service available called as CloudFront. CLOUD front, FRONT. So with the help of this CloudFront service, it will automatically create whatever the channel it is required to do. And you don't need to worry about at all. You have to just define where is your source information available, where is your source data available. That's it. The software as a service. You just define your application endpoint and then let Amazon to handle everything for you. And the second is where the data is cached. So the answer to that question here is edge location. So data is cached on the edge location, and there are more than 200 plus edge locations are available globally. There are approximately 25 regions available. On there, we have approximately 80 LD zone, and then more than 200 plus edge locations are available globally. Now the data is not going to be uploaded on all the 200s of edge location. the data is going to be uploaded from where the request is coming. Let's say if the request is not coming from the Dubai, then the data will not be cached in that region. If the request is coming from India, if the request is coming from Singapore, if the request is coming from Australia, so from where the request is coming, it will automatically cache the data. So CloudFront will automatically choose the right edge location to upload the data. There are certain countries where the AWS regions are not available, but AWS is managing an edge location there, so that if there is no region available, but if still you have a customer from that location, you can deliver the data easily. There are still a lot of countries where the AWS regions are not available, their data centers are not available, but still you will find a lot of companies or a lot of countries where the edge location is still available, so that the data can be nearest to their region. The data can be easily delivered to that region. In India, we have a Mumbai region which has 3 AZ and 5 edge location. And there's one more region which is upcoming, Hyderabad. It will take some time more, but that region is also coming. So if you want to know which are all the regions and everything, you can go to the AWS Global Infrastructure site. And here you will have all the information about the AWS Global Infrastructure. So you can see these are the different places where the AWS regions are available. And if I am correct, then 25 regions are there, 81 availability zone, and point of presence is 230 plus. 230 plus edge locations are available. So these are the blue dots where the AWS regions are available, and the orange one are in upcoming. As I mentioned, Hyderabad is in upcoming, whereas we have is in Mumbai. Even you will find in US there is one government cloud, US East and US government West. Yeah. So these are the 2 regions which is specifically designed for US government, US East and US West. And these are the 2 different Chinese regions, Indonesia and Beijing, which is again specifically for the Chinese countries or specifically for the China. So out of 25, if we ignore this 4, then you are allowed to design infrastructure in any region. You cannot design infrastructure in US West and US East and the Chinese region. You will require special permission for that, then only you will be allowed. But apart from that, whatever the regions you see here, you are free to go. In every region, there will be at least of 2 availability zones. And then more than 200 plus edge locations are available globally. It's not available here in this screen, but there are more than 200 edge locations are available. Now, edge locations are again a physical location, which is different than your AZ. Edge locations are completely separate locations than your availability zone, but there you can only have your cache data. You cannot create a server, you cannot configure any database, you cannot do anything. If you are using a CloudFront service, then your data will be cached in that edge location. Apart from that, you cannot do on the edge location. Now here, guys, I have a question. The region, availability zones, and edge location, whose responsibility is this to maintain? Purely responsibility of AWS to create, configure, maintain your infrastructure on that 3 locations. So that is called as global infrastructure. Now, guys, you must have know already how to create an AWS account. So once you have received an AWS account, on the right-hand side, you have a place where you can choose the region where you want to work. So you get a list of all the regions. Now, wherever you want to work, you can select the region. If I want to work in North Virginia, I can just click there. And now whatever I do will be in the North Virginia. So this is how you can select a region. So that is called as AWS Global Infrastructure. And the very first service that we are going to discuss today is EC2, which stands for Elastic Compute Cloud. It's a service that offers to you server. Now, for those who don't know what is server, A server is nothing but only the computer. Now, basically on a computer, you can do a lot of things. You can stop the server, or you can stop the computer when it is not required, or once your work is done, you can stop or shut down your computer. But that is not the case with the server. You have to run this computer, that particular server, all the time. Because if you stop the server, if you shut down the computer, all the application will go down. The request cannot come to your server again. So server is nothing but a computer, but we keep the server all the time running. We keep that computer all the time running, so that anytime you have any kind of request, that will be served. So a server is nothing but only the computer. Now guys, I have a question. What are the components of a computer? What are the components of a server? Let's say you want to buy a computer. So what are the things you will consider? CPU, RAM, storage, OS, IP address, or I can say network, applications, graphic card, GPU. So these are the basic things that you will ever consider when you want to buy a laptop, computer, anything. What about your budget? How much you want to spend? I do all the time. So these are the things that you have to consider when you want to buy a computer, a laptop on your on-premise. Now what we have to do, we have to consider the same thing. When you want to have a server, when you want to launch a server on the AWS cloud, we also have to consider all the same thing. The only difference is there is a change in the naming convention. The CPU and RAM together, they are called as instance type. The CPU and RAM together, they are called as instance type. This is only for you to remember the things easily. There are two types of storage: instance store and EBS, elastic block storage. The OS with optionally some application, maybe your Microsoft Office, SQL, or anything, and optionally some application called as AMI, Amazon Machine Image. The network is called as ENI, Elastic Network Interface. The GPU is called as GPU, and here we have certain pricing models. So the things that you do on your on-premise, the same thing we have on the cloud. Just these are the names given. So you need to remember this name. And if I ever ask you what is instance type, you should quickly tell me it's nothing but a combination of your CPU and RAM. What is AMI? It's nothing but an operating system. So these are the names which are available on AWS. Let's discuss one by one. The very first thing is AMI, Amazon Machine Image. It's nothing but your OS, and it might contain some applications optionally. For example, there is an AMI that offers you Ubuntu server with Python configure. Let's say there is an AMI which offers you Ubuntu server with Python install. Or maybe there is one AMI which offers you just plain core vanilla server. Or maybe another AMI which offers you Windows with SQL install. Or maybe another AMI with just Windows. So there are thousands and thousands of AMIs are available that offers you plain vanilla server or with the configuration of any other application. So you can choose whatever the AMI you want. Let's say I want to have a Ubuntu with Python install. So I can go with this AMI, so that once the machine is ready, I don't need to manually install the Python. So that I don't need to go and manually install the Python. It will be pre-configured with that machine. So AMI contains a template that contains your operating system with optionally some packages. If that package is good for you, you can continue with that AMI. Otherwise, you can go with a plain vanilla server. And once the machine is ready, you have full control to install whatever the application you want. Java, Python, libraries, whatever you want to install, you can install. So either you can go with the pre-configured AMIs, or you can go with a plain vanilla server, and then you can control whatever you want to install. Here also, once the machine is ready, you can control. If you want additionally some packages to be configured, you can of course do. So you are the owner of that machine, so you can do whatever you want to do. Now, what about the cost? So there are some charges available for the AMI. The charges depends on whether that will require license or not. Like this particular AMI, which contains Ubuntu and Python, both are open source.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you don't need a license here. So it will be freely available. This AMI might be freely available. But if you consider this Windows plus SQL, both the applications require license. So this will become chargeable. Now for the license, there are two options available. Either you can let Amazon to buy a license for you, so that as long as the number of hours you will run the servers, the license cost will be also involved. So one option is you buy the license on demand basis. Or the second option is BYOL, bring your own license. Sometimes what happens, your organization might already have a license copy purchased. They might be running on their own premise, so they might already have purchased the license. Or maybe you are getting into some discounts to buy the license. So you might have already purchased the license. So in that case, you are free to bring your own license and then register it with the AWS. And then you don't need to pay anything additional for that. So whether it's a Windows with SQL or just Windows, whatever the custom AMI you have with the pricing models available, with the license models available, for all the applications, you have this option available. You can buy a new license, or if you already have, you can have it that one. So such kind of various pre-configured AMIs are already available. Then there is one more option available called as marketplace. A marketplace is a place where different vendors have released their own AMI. A marketplace is a place on AWS where different vendors have released their own AMI, so that if you're looking for that particular solution, you don't need to install. For example, WordPress. WordPress is a blogging application. If you want to create an application, a site that where you can post a blog, so the most common tool is WordPress, which is also free to use. So if you want to install the WordPress, what you need to do, you need to have an operating system, you need to install PHP, MySQL, and WordPress. And then you have to configure all three together. Instead of that, you can go with the WordPress AMI. Instead of that, you can go with the WordPress AMI, which will automatically configure Ubuntu, PHP, MySQL, and WordPress. So your entire environment is ready. With a single click, your entire environment will be ready. You don't need to manually configure anything. So you can go with the pre-built AMIs. You can go with the marketplace AMIs. As well as you have one more option where you can create your own custom AMI. So guys, can you tell me why I need to have my own custom AMI? What could be that scenario where I might require a custom AMI? Standard software, several applications, different requirement, custom application installation. Sometimes you might have a scenario where the application that you want is not available here. The application that you want is not available here. In that case, you might require to create a custom AMI. But why I need to create a custom AMI? If that custom application is not available, I can go with a plain server. And later also I can configure that a custom AMI or custom application. Why I need to create a custom AMI in that case? I can go with a plain vanilla server, but later I can configure what is the customization I need. Yes, guys, very nice. So that we can reuse, we can replicate. Otherwise, every time I want to create a server, I have to do it manually. Every time I want to create a server, I have to do it manually. Instead of that, I can create a custom AMI which has already configured that particular custom application for me. Maybe the libraries I need, the platform that I need, the configuration that I need to, I'll do it for once. I create a custom AMI and the same now I can use. You can reuse the same AMI again in different region. So if you are planning to have an infrastructure in multi-region, we discuss the scenario multi-regional. So if you want to plan an infrastructure with a multi-region and the same configuration you want in another region or another AWS account, if we want to share the same AMI with a different AWS account, that can also be done. Or maybe different environment. I want to reuse the same custom AMI for my production, for my development, and for my testing. So the same AMIs can be again reshared. And just imagine, we talk about the auto scaling, not in deep, but at the high level, where the auto scaling will automatically create a new server for you. So in the auto scaling, if we are providing this custom AMI, then it will be very quickly able to launch your service. The auto scaling will be able to quickly launch your new server whenever there is a need, and the machine will be already pre-configured. So it has been very important part of your auto scaling. Having a custom AMI is very important in your auto scaling so that you don't need to do it manually. And lastly, it is very beneficial as a backup and restore. What if your servers are down? What if your infrastructure is down? What if some kind of failure is occurred? In that case, that custom AMI will act as a backup and you can relaunch your server quickly with that custom AMI. So having a custom AMI for your application is very important. Whether it's a production, dev, or test environment, having a custom AMI is very, very important. So that every time I want to launch a server, I can use the same custom AMI. That's fine. But what about the cost? So there is no charges of creating a custom AMI. However, the storage is chargeable. So to store that your data, to store that custom AMI data, let's say if it consumes 8 GB, then you have to pay only for that storage. Apart from that, there is no charges of creating custom AMI, managing a custom AMI, no charges at all. So that is the very first concept, custom AMI or AMI, which will help you to launch your resources. The second thing what we are going to discuss quickly is instance type, which is nothing but a combination of your CPU with RAM, which is nothing but exactly your hardware. What configuration of hardware you want, you can choose with the instance type. Now to choose this, there are 5 categories. General purpose, compute optimize, memory optimize, storage optimize, and accelerated computing. These are the 5 categories available under the instance type. And guys, if you are planning for a certification, you should remember all the 5 categories. So what is general purpose? A general purpose, as its name says, for your general workload. If you have an application that doesn't have very high traffic, it's just a normal application with a low traffic, and you want to do any kind of complex work, if the application is not going to do any kind of complex work, you can go with the general purpose. That gives you balanced performance, balanced cost, and balanced application. So balanced traffic you can maintain, balanced performance, and balanced cost will be there. So when an application that doesn't need to process a large any kind of data, that doesn't need to process any kind of complex operation, for general workload, if you want, you can go with the general purpose. If you have an application that requires more CPU, that is for CPU intensive workload, compute intensive workload, where more CPU power is required. Like when you want to parse some data, when you want to do some kind of algorithms you want to run, or when you want to do some kind of calculations. So in that case, you will require more computation, more CPU power will be required comparatively to RAM. So when you need more CPU power than RAM, you can go with the compute optimized category. For example, this kind of application. And in case if you require more memory, then you go with the memory-based optimized machine. For example, if you want to run in kind of database, which require higher IOPS, so you will require more RAM power. Or any kind of caching system, if you want to design, you will require more RAM power. In that case, you can go with the memory optimize. The next is a storage optimize, which offers you higher throughput. Throughput means the amount of data that you can access per second, the rate at which you can access the data. So let's say I have terabytes of data. So for the accessing of the terabytes of data, I will require higher throughput so that the data will be accessed and processed fast. So the rate at which the data is accessed and processed is called as throughput. So if you have an example like a big data application, if you have a big data application where data size is very high and that you need to process, in that case, you will require more throughput to quickly access your data faster and process it. So for higher throughput, you go with the accelerated storage optimized category. And accelerated computing when you need GPU. So these are the 5 categories. Now, as a solution architect, this is your responsibility to choose the right category. So you need to check with your customer what kind of application they are running. Do they need more CPU, RAM, storage, or GPU? And based on that, you have to choose the category. Now, inside each of these categories, there are various subfamilies available, like T2, T3, C5, R5, varieties of categories are available. These families represent one of the processor. Like T2 family represent Intel Xeon processor. And 2 represents second generation. So this is second generation of the Intel Xeon processor. So in every categories, there are many subfamilies are available which represent one of the processor. Intel, AMD, CUDA, NVIDIA, varieties of processors are available. So again, you can decide what kind of processor you want. And then in each of this family, there are again configurations are available. Like T2 micro, T2 small, T2 medium, T2 large, T2 XR, T2 10XR, T2 4X large, T2 XX large. Whatever it is, there are varieties of configurations are available, which defines what should be the configuration. So T2 micro represent 1 core CPU, 1 GB RAM. T2 small represent 1 core CPU maybe, or 1 core CPU and 2 GB RAM. T2 medium will give you something else. So again, you have a list of configuration with number of cores of CPU and GBs of RAM. And what you want, you can choose that. Okay. Now the question is how you will do the selection. Category wise, it's easy. Categories wise, it's easy. But at the instance size level or at the family level, it is actually very difficult to remember and to analyze. So there are 2 things. First, from the exam perspective, you don't need to remember any families because there are lots of families are available and you cannot remember all of them. You have to just remember the 5 categories. That is more than enough. Now, when you are actually working on the AWS, how you select a right instance type. Basically, based on your application, you have to just choose the category. And then you can launch a machine with any instance type. Let's say I go with the T2 micro. So I think that 1 core CPU, 1 GB RAM is sufficient. First of all, your client will tell you what kind of configuration they are already running or what kind of their requirement is. So you can check accordingly. Otherwise, if they do not tell you, if they are not even aware of it, you can launch a machine with the basic configuration and you can deploy that application. Once you deploy the application, now you can do the performance testing. The kind of performance that what you need is available with that machine or not. You can test it. If you think that is good to go, that's perfect. Otherwise, you can upgrade the machine from T2 micro to T2 small. And again, you can test or T2 large or X large or 10X large. Or maybe if you think later that, no, the machine has to be from the compute optimized. you can upgrade the machine from the compute optimized family. So you don't need to do a deep analysis on what kind of machine you want. You can launch a server, you can deploy the application, you can test it, and then you are ready. You are always okay to upgrade or downgrade the machine. You have that kind of flexibility. So you are allowed to make a mistake. You are allowed to do the trial and test and then choose the right service. So when you are actually working on AWS account, you don't need to worry. You can go with some configuration and then you can try and test. Pricing model. And there are 5 pricing models available. One is just someone mic is on, guys, please mute. The very first is on demand. Second one is reserved. Third is spot instance. Fourth is dedicated instance. And fifth is dedicated host. These are the 5 general, you can say, pricing models that you can choose. So let's imagine this is a AWS data center. Okay. The very first category is on demand. As the name says, on demand, that means you don't need to do any kind of commitment. If you want a server right now, you can have a server. So what I'll do, I'll just make a request that I need an on-demand server. And what will happen? Amazon will allocate the space. Perfect. No commitment required. And you pay for what you use. Let's just say for a machine, the cost of on-demand server is $1 per hour. Let's just assume for easy reference. Now here you will be charged $1 per hourly basis for how long you use the server. You don't need to do any kind of commitment. But in case if you guys are sure that a server will be required for the next few months or few years, that this is my base capacity that I need to run all the time for my production or for something else, then it's better to reserve the capacity. So there are 2 options here available for reserving the capacity, 1 year or 3 years. These are the 2 terms available, 1 year and 3 years. There is no 2 terms available for 2 years, 4 years, 6 years, nothing. It has to be 1 year or 3 years. So here we do the commitment that I will use that particular machine for next 1 year or 3 years. And then you have to also do the payment. So how you are going to do the payment? Completely upfront payment, partial upfront, or no upfront? So based on your payment and based on the number of years of commitment, you will get a discount. And you can have a discount up to 60% on an average, depending upon your payment and depending upon years of commitment. You can have up to 60% of discount. So generally, it is a good idea to go with the reserve instance and do the commitment if you are sure that this amount of servers will be required for the next few years. So let's say I purchase the resource and let's say the server is available to me at, let's say, $0.4 per hour. That is approximately 60% discount on the on-demand. So when I request, what will happen? Amazon will allocate the reserve instance. Now the third concept is very, very good. Here you can have up to 90% of discount, but that's not guaranteed. In the on-demand, it is guaranteed that whenever you want a server, the server will be available to you. In the reserve machine also, when you do the commitment, when you want a server to be available, it makes sure that the server is available to you. But that is not the case with the spot instance. These are not reliable. So let's say the price of a spot machine is $0.2 per hour. Let's say up to 80% of discount we have got. Now here I have to bid. Let's say my bidding price is $0.3 per hour. I have set the bidding price to be $0.3 per hour, which is higher than your current price. So now what will happen? As you can see in the data center, there is only very small demand which has consumed the data center. A lot of free space is available. There is a lot of unused capacity available. So when you use the unused capacity of AWS, AWS offers you discount. So the spot machine will be allocated to me. So the spot machine will be allocated to me. What is spot machine? When you use the unused power of AWS, AWS gives you the discount. Now, why this machine is unreliable? Now, let's say, as I mentioned, the priority is given to the on-demand and to the spot instance. Sorry, to the on-demand and the reserve machine. It is always guaranteed that the on-demand and the reserve machine will be available to you. So let's say now demand of the on-demand has increased. And similarly, the demand of a spot machine has also increased. And now you can see a very small capacity left. That means when the demand increases, the supply becomes low. When the demand increases, the supply becomes low. And when this happens, the price of a spot instance will automatically change. Maybe from 0.2 to 0.23, maybe 2.5, or maybe it will reach to $0.3, which is your bidding price. So once the server has reached your bidding price, Amazon will send you a notification that you have reached your bidding price. If you want to continue to the server, you can increase your bidding price. Otherwise, you had 2 minutes to take a backup. After that, the server will be automatically deleted. You have 2 minutes to take a backup. Otherwise, the server will be deleted. And sometimes what happens, due to very high demand, you won't even get that chance. Because the priority is given to the on-demand and to the reserve. For the spot instance, it is never a guarantee that the machine will be available to you. Sometimes you want a spot machine, but that particular instance type might not be available. So it is not guaranteed that all the time a spot machine will be available. So that is why these are unreliable. Now with that, I have a question. If the machine is not reliable, why you will ever consider having such kind of system? Now, what AWS suggests here is you can intelligently have different pricing models. What does that mean? Let's say there is some traffic which is all the time is available on my application. That is a base traffic. Let's say 4 servers are always required to handle my basic requirement, basic server capacity all the time. So what I can do, I can have a reserve instance. I'll go with the reserve instance and I will buy 4 servers. So here on the 4 servers, I can do a lot of cost control. Now, when the day starts, the traffic also starts growing. After let's say 7 a.m., 9, 8 a.m., the traffic starts growing. So whatever is the demand during the daytime, it will be handled by the on-demand. With the help of auto scaling, whenever required, it will create the servers and it will delete the server. So what is the traffic during the daytime? That will be handled here. And then optionally, I can say, if suddenly the traffic goes very high beyond a particular threshold, that is my on-demand also has some maximum capacity. Let's say the on-demand is also having capacity of 4. So 4 plus 4, 8. If there is a traffic which is very suddenly, and that requires additional number of servers, I can handle that amount of optional things with the help of Spot. This is generally not there in our application. This is not generally the traffic seen in our application to this level. But sometimes, maybe once in a month or once in a year, once in a while, due to some reason, there is a suddenly spike in our application. So this is not usual. This is very rare. In that case, you can handle that kind of small traffic with the help of Spot instance. So for your same application, you can choose to go with a different pricing model. A single application can be run on using all the three pricing models. And this will help you to reduce the cost of your infrastructure. I can also consider the Spot machine if I want to do any kind of batch operation. Usually the batch operation is a few hours, 2 to 3 hours, 4 hours. So for that, I will launch a Spot machine for short duration, and I can also use it for the production. So these are the three pricing models. Now, if you guys remember the previous chart, all these three are available in the same data center on the same hardware. Your on-demand, your reserve, and your Spot. So this is called as shared tenancy, a shared model, where a single hardware is shared between multiple customers. Now, what is the next? Dedicated instance. That is, a single machine is dedicatedly available to you on a dedicated hardware. So this particular hardware is not shared with any other customer. This is completely dedicated to you. But here also, you don't need to do any kind of commitment. No commitment required, and you will be charged per hourly basis. So definitely based comparatively to your on-demand. On the on-demand also, we do not do any kind of commitment. Here also we are charged per hourly basis, but this is on the shared one, and this is on the dedicated. So definitely the cost will be little high. So what is dedicated instance? It's just like on-demand, but on a shared tenancy. Sorry, but on a dedicated tenancy. The entire infrastructure is dedicated to you. And dedicated host means a giant hardware is allocated to you. A giant hardware is allocated to you. And now you can launch the number of subnets or the number of servers you want to have. 1, 2, 3, or whatever the size you want. So in a dedicated host, an entire host is allocated to you. Now, how you handle the entire host, how many servers you create, or what configuration, it's up to you. So why would one will go with this option? Maybe a company will have some kind of compliances and they want to be on the dedicated one. So in that case, they might go with the dedicated instance. And dedicated hosts, generally these are used when you want to have a node-to-node communication. If you have an application that requires a low latency node-to-node communication, like a cluster, in that case, a company might choose to go with a dedicated host. And when the security is very important, if you have such kind of compliances, then only you need to go with the dedicated. When the hardware is dedicated to you, is it a private cloud? So though the infrastructure is dedicated to you, but that doesn't make this entire infrastructure to be private. Just your server is private. The other components, what you will use, maybe the storage, maybe the network or any other database or whatever it is, that will be still hosted on the public endpoint. So even if you are on the dedicated instance, that doesn't make that the machine is on the private cloud. The cloud will be the public only. Just because of your compliances, you can have it on the dedicated machine. So these are the 5 pricing models: on-demand, reserve, spot, dedicated instance, and dedicated host. Now guys, just $1 per hour, $0.4 per hour is just an example. Depending upon your instance type, whether it's a T2 micro, whether it's a T2 large, T2 X large, the charges will go up or down. Okay, it's just an example of having a $1 because $1 is too much. So it's not that very high. Now, the last component is storage. and then we'll see the lab. So there are two types of storage. One is called as instant store, and second is EBS or elastic block storage. Now, instant store is ephemeral storage system. Temporary non-persistent storage system. Now, why you will have an ephemeral non-persistent storage system? Because if you have a server with a temporary storage, and if a server goes down, you will lose all your data. The data only persists as long as the machine is running. In case if you stop the machine or in case there is a failure, you will lose all your data. Okay.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what you get in the instance type is, it gives you higher IOPS at very low cost. What is IOPS? Input output operations per second. That is the number of operations you can do on your data, the number of operations you can do on your storage. So higher the IOPS, the faster will be the processing.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
The higher the IOPS, the faster will be the processing. Whenever you choose to go with a higher IOPS, generally that adds the cost. But this instance store gives you the cost benefit. Now that is fine. But what are the applications where we can use? Generally, it is used in the big data. In the big data application, we have to process a large amount of data. So we will require a higher IOPS. So in that case, instance store is widely used. And this is not our discussion, but big data application have replication factor. That replication factor replicates your data across multiple nodes. The same data will be replicated to multiple nodes. So even though if the data lose from one of the server, still you will have a backup in another server. You will have a copy of your data in another server. So in such cases, when you have a data applications, in that case, this kind of ephemeral storage can be used. It can be also used for your testing purpose. It will again offer you low cost machine. So these are the use cases for the instance store. If you do not want the non-persistent, you can go with the persistent storage called as EBS. It offers you persistent. Even if your server goes down, your data will still survive in the EBS. So it comes with 99.99% of availability guarantee. How it provides the 99.99% of availability guarantee? What if the resource you will create? Amazon will have one backup copy. Amazon will replicate the data one more time, so that if one copy goes down, Amazon can recover your data from the another copy. And in case if your server goes down, your data will still survive in the EBS. So that offers you persistent. Now, how it offers you persistent, we'll discuss that later. But at this moment, our discussion is what is EBS. So it offers you higher IOPS. It offers you booting. So if you want to boot your server, if you want to install an operating system, if you want to install your application, then SSD is required. So generally our C drive is always SSD. Although by default, all your drives are SSD, but nowadays we are having a hybrid option that you have SSD and HDD both in the single drive. but still the machine will be hosted on the SSD. So your booting, your installation of the applications are done on SSD. Even the same SSD is also used in your mobile phone. So this mobile phone is also booted on the SSD. Your application, whatever you install, is done on the SSD. And SSD is like a pen drive or any external hard drive. So guys, my question here is, when you want to buy a pen drive or hard drive, what are the properties you check? The data transfer speed, generally measured is Mbps, the speed at which the data can be copied or processed. So in the EBS, again, you have both the options available on the AWS, SSD, HDD. SSDs are used to launch a server, and then you can additionally add the HDD volumes if you want. So in this, again, we have two categories: general purpose. As I mentioned, general purpose is for all your general workload. You can go. And the second one is provisioned IOPS. In HDD, you have throughput optimize and cold HDD. These are the four options we have on the AWS. So general purpose, as we discussed, for the general workload for all your application, you can go with the general purpose. Now, in case if you are running any kind of mission critical application, like database, data warehouse, where you want to run any large amount of processing, where you want to do a lot of IOPS is required, like for your big data application as well. When you need higher IOPS to process your data for running your database, you can provision the number of IOPS you want. Now, based on your IOPS, you will also get charged. So this might sometimes become costly. It totally depends on the number of IOPS that you define. Now, with the general purpose, you can create a volume of minimum 1 GB, maximum up to 16 terabyte. A single volume can be of minimum 1 GB, maximum up to 16 terabyte. Now, this is a limitation of a single volume. On a server, you can also attach multiple volumes. So multiple 16 terabytes of volume can also be attached at the same time. It's just like on your one computer, you have attached multiple pen drives. So that can also be done here. You can attach multiple volumes of SSD possible. And for the provision IPS, minimum is 4 GB, maximum is 16 terabyte. For the HDD, minimum is 500 GB and maximum 16 terabyte. As you can see, 500 GB. So we know this. This is used when you have a higher amount of data, when you have large amount of data that needs to be stored. In that case, we use the throughput optimize. So the throughput optimized storage is used when you have a data which is very frequently used. If you have data that requires a frequent access, you go with the throughput optimize. And cold HDD, as the name says, cold, for the infrequent access data. If you have data which is not very frequently used, but whenever you want the data should be available, in that case, you can go with the infrequent or cold HDD. Among these four, the cold HDD will be the very cheapest because it is used for the infrequently accessed data. And comparatively between SSD and HDD, of course, the HDD will be cost efficient. But it cannot be used for booting. It cannot be used for mission critical application. It can be only used when your data size is very high. So SSD, HDD, and all the four types has their own use case that you need to understand. Now, guys, I have some scenarios that will clear what is EBS. Let's just say this is a region. In region, I have availability zone 1 and availability zone 2. Or in short, let's say these are the two different data centers. in one data center, you have created a server, or let's say you have created 2 servers. And in another AZ, again, you have one more server. Perfect. Now let's say you have created one EBS volume. This is the EBS volume. And this EBS volume is currently attached to this machine. So my first scenario is, can the same EBS volume can be attached to another server in the same data center? The volume which is attached to one server, server number 1, can be also attached to the server number 2? The answer is yes, as well as no, under a condition. You can attach it to another server, but not at the same time. You have to detach it from the server number 1 and then attach it to the server number 2. Just imagine. Now in front of you, you have 2 computers and there is 1 pen drive. Can you attach 1 pen drive to 2 machines at the same time? That is not possible. But I can detach it from one machine and attach it to another machine. That is one at a time I can do. So the same concept. One EBS volume can be attached to multiple servers within the same availability zone, but one at a time. Now, can I attach this volume to a server in another availability zone? The answer is you cannot attach. Let me explain. Let's say this is your office and this is, let's say, your home. In your home, you have one pen drive. And right now you're in your office. So the pen drive which is available in your home, can you attach it to your computer office, to your office computer? That cannot be possible. So if I want this data to be also available here, then how I can do? Because we have discussed that I should design an application in multi-AZ. I should design the application in multi-AZ so that it creates a high availability. But the challenge which I have is, how can I share my data? So just a one-step thing, just one-click thing. You have to select your EBS volume and click on create a snapshot. And this will create a snapshot in that particular region. That means, again, let me repeat. You select the volume and click on create a snapshot. And it will create a backup file. Now that backup is created at the region level. It is not an AZ specific, it is region specific. Now this backup copy I can use and create a volume in another AZ. I can create a volume in another AZ and I can attach it here. So I select the volume, create a snapshot. The snapshots are at the region level and I can restore the data in another volume in another AZ. Or I can also share that volume to another region or another AWS account. So when you create a backup of that volume, you can restore it on a different AZ, you can restore it in a different region or in a different AWS account. So for the AMI, we discussed that having a custom AMI replicated on another region or another AWS account is a good idea. So similarly, the volume, the storage can be replicated to a different AZ, to a different region, or to a different account, which can be used for copying purpose, replicating your data, as well as for the disaster planning. There is still a problem. What is the problem? The data what I have on this server, I have taken a backup, and now the data is available here. But the data which I have replicated is not a continuous backup, it's a time backup. So when I have taken the backup, that data I will be able to restore. Whatever the new data which is coming in will not be replicated here. In short, These two servers are not synchronized with the same data. These two servers are not synchronized with the same data. Just remember this scenario, that though we have taken a snapshot, the data is not real-time backup. So as of now, what we need to remember in EBS. EBS is first of all a persistent storage. It is a direct attached storage system, which is very important. Direct attached storage system offers you low latency because the storage is directly attached to your server. So there is no network issue, there is no internet bandwidth issue, nothing at all. So data will be always available to you in a very low latency. That's an advantage. Then volumes are AZ specific. And for the backup, you have to create a snapshot, which are region specific. So these are the few things that you have to remember. Now to get it more clarity on what we have discussed so far, let me just show you how to create a server. So today, right now, I am on my AWS Management Console. I can choose a region where I want to work. So I prefer the Mumbai one, which is nearest to me. And from the services, I can, that is virtual server in the cloud. So on the left-hand side, you have a complete panel of what resources you have and everything. 1 second. And this is my EC2 dashboard. So we have to launch a server. I just click on launch an instance. Then step number 1, choose an custom AMI, choose an AMI. So these are the pre-configured AMIs. Amazon Linux AMI, as you can see here, what we have, a basic Linux machine with system 219, GCC compiler, GLI PC compiler, and a few other latest packages are there. This is a plain vanilla server of Red Hat machine, plain vanilla SUSE, Ubuntu, Microsoft. Now you can see here we have combination. Microsoft Server 2009 with containers. So there is some container already configured here. Here it is configured with SQL 2017 standard one. This is 2017 enterprise. 2019 standard, 2019 enterprise. So you can see here varieties of combinations, configurations are available. Now guys, as you have created a new AWS account, so you are eligible for the free tier. So make sure that you use an AMI which having a tag of free tier so that you will not be charged. Though the Linux machines are free, they are open source, not the Red Hat. But here also for the Windows also you are free to use. So you don't need to pay anything license for the Windows machine. But make sure that you use this AMI and not use this AMI. Otherwise you will be charged. Now these are the pre-configured AMI. If you are not easy to find what kind of AMI you want, you can click on the community AMI. And then based on the operating system, based on the architectures and everything, you can choose what kind of AMI you want. These are again pre-configured AMI. You can go with the marketplace AMI if you want. Like varieties of companies have released their own AMI. You will find based on the product, based on the use case, you can search it here. And then on the left hand side, you again have my AMI. So in case if you have created your own custom AMI, then you will find it here. Like this is the one which I have created earlier. So this is my custom AMI. So if you want to use this one, you can continue with that. Now, as a beginning, we'll just start with the Linux AMI. So I'll just start with this one. The second option is choose an instance type. And here you will find a list of the instance family. T2, T3, T3, T4, A1, C4, C5. Large amount of categories are available and their generations. But you are only eligible for the T2 micro, which offers you 1 core CPU and 1 GB RAM. So as a part of the lab, you have to stick with this T2 micro only. If you use any other, you will be charged, even if you go with the T2 nano. So just select the default one and you can continue. Now here you have a lot of options where you can configure your machine, like your network, like your securities and other thing. But as of now, we have not discussed any of this concept. So as of now, I'll just go with the default setting. No, will not touch anything here. And this is your storage. So here you have general purpose and provision IOPs. Now here, these are two things which are very important. First, the amount of storage that you want. So guys, if you are taking a note, take a note here. This can be your exam question. If you want to launch a Linux machine, minimum 8 GB storage is required. If you want to launch a Linux machine, minimum 8 GB is required. And if you want to launch a Windows machine, minimum 30 GB is required, 30. So this is the minimum requirement to launch a server. And this configuration is again very important, delete on termination. If I uncheck this option, then what will happen? Due to any failure, if my server goes down, then my data will still available on the storage. That is, if due to any reason, if my server goes down, my data will still survive in the storage, which I can restore at any point of time. But I choose this option, and in case if the server goes down, it will also take my storage also down. And then I won't have access to that. So generally for the production one, we do not choose this option. And then you can here add a tag. Tag is nothing but just name or environment or something you can add. Let's say Linux server. Tags are absolutely free. It will help you to, filter your resource, to manage your resource more easily. So having a good names or good tags is very important. You can add any random tags here if you want. It's not mandatory one. And now the last thing is security group. So security group. So basically, let's say this is a server. Now to this server, some kind of request may come, and the server will send a response to that request. Now the request travels on a particular port. Like if you are making a request like HTTPS, this is HTTPS, so it will be like 443. If it's HTTP, it will be 80. So there are varieties of ports are available on which you can make a request and the response you may receive. So what is the firewall? Firewalls is a security control that define what kind of traffic can come, that is who can and for which port the request can come. This is called as inbound. This is called as outbound. The request when coming in called as inbound, the request which is going out called as outbound. So that is what we have to control here. The best part is by default, all the ports are denied. All TCP, all UDP ports, everything is denied in a default security group. We have to just define what rules you want to allow. So let's create one Linux security group. And what kind of protocols you want to allow, you have to specify. Now, first of all, I will attach SSH. SSH is required for the Linux machine to log into the server. If you want to log into the server, SSH is required. If you want to log into your Windows machine, then RDP will be required. Okay, so these are the two protocols which are minimum required. This is a Linux machine, so we don't need a Windows. I can remove that. And in addition to that, any other port required, you can add. Let's say I want to add HTTP. So whatever the port you want, port range you can define will be available here. Now from where the request should be coming. So maybe the SSH request should be coming only for my organization network. For the more security, I can provide my network organization range here. So if a person is making a request from the organization network, it will be allowed. So if you have such kind of scenarios, you can also define it here. Otherwise, you can say 0000, which is open to the world. A request can come from anywhere in the world. So as of now, we can go with this option. Review and launch. Now the last thing is we have to create a key pair. What is a key pair? Key pair is nothing but an authenticated key to connect to the server. If you want to connect to the server, you will require a key pair. Let's say I create Feb June key pair, and I can download this key pair. Okay, there is some issue with my browser, so I'll go with the existing one. I have to manually create it. Okay, so I've just created a key pair manually. And again, I'll go and launch a machine, keeping the same steps again. So what is a key pair? A key pair is nothing but an authenticated key which is used to log into the server. So those who want to log into the server, they must have a key pair. If you do not have a key pair, you won't be able to connect to the machine. Now key pairs are region specific. So once you have created a key pair, you can attach the same key pair to any number of machines within the region. For every server, you don't need to create a unique key pair. For every server, you don't need to create a unique key pair. A single key pair can be used for multiple machines. So you can create the key pair, you can download it, and here you can select and acknowledge and log in for launch. Now you can see the machine is in the pending mode, which will take few seconds, 10 to 15 seconds max, and then your machine will be ready. And you can see our machine is ready to use. The machine is in running state. Now what I'll do at the same time, I'll also launch a Windows machine. And then we'll see both how you can connect to a Linux machine and how you can connect to a Windows machine. So I'll follow the same step, launch an instance, but this time I'll choose Windows Server. Keeping all the configurations same. You can see here the minimum storage is now 30 GB. I can add a tag, name, Windows, and here I can create a Windows security group where the RDP is open. You can remember this port number also. The default port number is 3389 for the RDP. Remote desktop connection. Now guys, this is my Linux and this is my Windows machine. Now to connect to this machine, there's a different procedure. So right now, if you have a Linux machine, Mac machine or Windows machine, the procedure to connect to this machine will be different. First of all, I'll show you if you have a Linux or Mac machine right now with you, and if you want to connect to a Linux or Windows server, how you can do. And then I'll show you for the Windows user, how you can connect to another Windows or Linux machine. So I'll show you both. Whatever is your system right now with you, you can continue with that. First of all, with the Linux machine. For the Linux machine, what you can do always, you can click on connect and you can do browser based connection. Easy to install connect and click on connect. And from the browser itself, you can log into the server.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So you can see I am connected to 172.31.38.50, which is nothing but your private IP address. 172.31.38.50. So we are connected to a machine. And now you can do whatever you want. Whatever you want to install, you can do. Let's say I want to install Apache server. So the package name is HTTPD. HTTPD is a package name for Apache. If I hit, it will download the Apache web server. We can start the service HTTPD start. The server is now running. And I can configure the Apache server to be auto login. chk config HTTPD on. Don't worry about this command. I'll explain later. So with these three commands, my Apache is now up and running. If you want to test, you can copy this public IP and hit from the browser. And you should see one test page. So basically, now what I can do is, if I have any kind of domain, I can connect this domain with that IP address. So that whenever the request comes to my domain, the page can automatically get hit. But this is not what I want to show. I want to deploy an application. I want to deploy a website. So here you can see you can add now a content to your directory via www.html. So this is your directory, which is already available in your server. Now, how to go to this directory? For this, you need to learn Linux. Now, as of now, if I do pwd, you can see my present directory. I am currently in my home and under EC2-user. Now, where I want to go? I want to go in this particular directory, /var/www/html. So what I'll do is I will pass the command cd, change directory. I want to change my directory to var w.html. So if this is something which is completely new to you, you have to learn the Linux. So what I'll do is I'll download one HTML template from internet. Or you can also create your own free HTML template if you want. I'll just download it from the internet for free. Let's say I want to deploy this look good. So I'll just copy the link, right click and copy the link, go to your server and say wget. Again, wget is just a command to download the file and paste the link and hit enter. That will download the zip file. You can see devfolio.zip file is now available. So let's unzip. Now you can see the files have been unzipped, but that is available inside one of the folder. So I will move the content from that folder, all the files, to my working directory var w.html. And everything is now available here. The index.html, the JavaScript, the images, the CSS, everything is available. Now guys, if you just refresh the page, the same IP address, let me know what you see. So what you need to check here is, if you want to deploy your application, how fast you can do. If I have an on-premise infrastructure, I have to do a lot of things. I need to buy and do all the things. But here on the cloud, it will be super quick. And that is why various startup companies can design their idea and run their applications on the cloud easily. So this is how you can deploy an application. And this is how you can connect to a machine, if your machine is a Linux machine. Now, the second thing is, if you have a Linux or Mac machine, and if you want to connect to a Windows machine, then how you will do? So for that, what you have to do is, for that you need to download remote desktop connection. There is an application available called as remote desktop connection. You can download it from your app store. So this is downloaded, and you have to add a PC. And here you will provide the public IP address of your server. And click on add. Then double click. It will ask you the credential, username and password. So where is the username password of this machine? You have to click on connect and you need to click on get password. So this is your username, administrator. Click on get password and provide the key pair which you have downloaded. So I'll just provide my key pair, June, and decrypt the password. So this is your username, this is your password. Provide that here. And click on continue. And you can see we are connected to a Windows machine. We are connected to a Windows machine. So for the Windows machine, you get a console, you get a UI. So you can easily manage your applications and everything here. But for the Linux, you don't have any kind of GUI. So you have to learn commands, how to manage, how to navigate within your server. So this is how, if you have Windows machine or Linux machine, how, or Mac machine, whatever it is, how you can connect to a Linux machine and how you can connect to another Windows machine, from Linux or Mac to Windows and Linux and Mac to Linux. Okay. The second thing is, if you have a Windows machine, how you can connect to a Linux machine and how you can connect to a Windows machine. So even if you have Windows machine, the first thing is, if you have Windows machine, if you want to connect to a Linux machine, you can again do the same thing. Click on connect, browser based connect, and you can connect. Or you can do one more thing. You can download a putty tool, and via that also you can connect. So basically, guys, I don't have any kind of Windows machine with me. I have Mac machine, so I cannot demonstrate you. But I can use this Windows server to demonstration for demonstration purpose. But for this, I have to do some kind of configuration. So just give me 1 minute. You don't need to do any of this thing, because this is a server. This is not my local machine. So I only need to do. Okay. So now you and I are on the same page. You have created a server and you have downloaded one key pair. So I also have one Windows machine and I have downloaded one key pair from the AWS console. So now we are on the same page. Now what I have to do is I have to download one tool called as Putty, P-U-T-T-Y. And here you will come with one link, putty.org, something will come. So this is the link. You can choose between 64 or 32 based on your application, and you can download. Okay. So what we have done on our Windows machine, we have downloaded a tool called as Putty. Now, when you have downloaded the key pair was .pem file. The extension of the file was .pem. But the problem is Putty do not understand the PM file. What Putty understand here is PPK. So we have to do one-time job again. You have to click on Putty Gen. This is a one-time job. So click on the Putty Gen. And we will convert the Putty PM file to the PPK file. So just follow the step. Here we have to click on load. And that key pair file, which is available on my desktop, I have to select that. So key pair, open. And then I have to click on save private key. Say yes, give a name, key pairs, save. And you can see it has converted the PM file into PPK. If I click on the properties, you can see it is .ppk. Then, now again click on here, click on Putty, and simply select the simple Putty. Now here what you have to provide is the username. Username will be EC2-user. If you're not sure what is your username, you have to just click on connect. And here you will find the name of the user is EC2-user. At the rate, the public IP you have to paste. EC2-user at the rate public IP. Now the second configuration, what you need to, on the left hand side, you have a SSH. So expand the SSH and then click on auth. Do not expand it again. Repeating again, you have to expand the SSH and then click on auth. You don't need to expand it again. And then browse the PPK file that you have created. Browse a PPK file that you have created, open and open.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
And you are connected to your machine. So I have shown you both the ways. That is, if you want to connect via a putty tool, you can connect it. If you think this is little difficult, you can connect from the browser also. So simply you have to click on connect, connect, and connect. What is the difference between these two? From the browser-based connection, you can do only one setup, one at a time. You will be able to connect to one machine only one at a time. But with a putty, you can connect to multiple machines at the same time. So that is why putty is used. Now putty is just a one open source tool which connects the SSH connection. There are hundreds of thousands of tools are available on the internet. So if you find any other tool which is more easy to use, you can also choose that. This particular tool is easy to use and it is free. That's why I've shown you. If you know any other tool, you can of course use that. So this is how you can connect from Windows to Linux. And the last thing is Windows to Windows. And for this, you don't need to install anything. Just click on your start button and search for RDP. And the remote desktop connection will appear. Click that. Provide your Windows Server public IP. So select your Windows Server, copy the public IP and paste it here. Click on connect. It will ask you username password. And what you have to do for the username password, click on connect. Click on get password. Provide your PM file and set decrypt password. So this is your username, this is your password, provide that here, and you will be able to connect to the machine. Now, of course, I cannot do this because the same machine I am already connected. So this is how you can do the connection. Okay.
For now, guys, let's start with the first service, which is AWS EC2, and let's see what is it all about. So guys, Elastic Compute Cloud is nothing but a server. It's a raw server. It's just like a fresh computer that AWS gives to you. So what you basically do is you ask AWS for server, right? And that service is called EC2. So what you do is you specify the kind of processor that you want, you specify the kind of RAM that you want, and then you click on launch, and what happens after that is you get a server which is basically of that exact configuration. Now what you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's a Windows machine, you will connect through RDP, right? And once you connect to it, it'll give you the UI of how an operating system actually is. If you installed it on your local, it'll be exactly the same. It's just that now it has been basically launched on the infrastructure of AWS, and that can be accessed using various tools like the RDP tools or SSH tools. I'm going to discuss more about EC2. I'm going to basically launch an EC2 instance in a moment. But before that, let's discuss all the services which are there in compute, and then we'll do that EC2 demo as well. Right? So guys, Elastic Cloud Compute, like I said, it's just like a raw server that is given to you. And on this raw server, you can install anything, you can make it anything, you can basically build it, make it a web server, you can make it a database server, it can be anything, right? That is what EC2 is all about. Now in the diagram, as you can see, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of launching, of creating a EC2 instance and then installing some softwares on it, and then you can launch multiple copies of that particular EC2 instance, so that you don't have to launch, or you don't have to specify, or you don't have to install all the softwares all over again. You can create multiple copies of the EC2 instance again, right? And at some point of time, if you feel you want to increase the configuration of your system, you can also do that, right? Let's say if my RAM was 8 GB over here and then I want to make it 16 GB, even that is possible in EC2. And that is why the name is Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease the size of the instance configuration as and when required, right? So guys, this was about Elastic Compute Cloud, that is EC2, right? Our next service is AWS Lambda. Now AWS Lambda, again guys, is an automated version of EC2. It's an advanced version of EC2, but with some restrictions. Now what are those restrictions? It cannot deploy an application. You cannot upload your website on it, and it cannot host an application for you. What is AWS Lambda? AWS Lambda is basically just used for doing your backend processing. Now, what is backend processing, you might wonder. So let me give you an example. Let's say you have an image processing application. So what do? You have a UI or you have a website through which you can upload an image, and what that website does is it stores the image on its storage, and then it reduces the size of the image, right? And then you can download it again. Now you might be wondering, this is one website, so ideally everything should be happening on one server in this case, but that is not the case over here, guys. So what happens is your web application is on a separate server. The processing happens on a different server, right? And AWS Lambda specializes in processing. Now, why is AWS Lambda preferred for processing? Is because when you launch a server, guys, you have to select the configuration that you want, right? You have to select the processor, you have to select the RAM. With AWS Lambda, you don't have to specify any configuration. You don't have to choose what server size should be for my application to cater to the workloads that are coming in. AWS Lambda, what it does is it sees what kind of workload it is being given. It automatically scales up if it has to in terms of its configuration, and then executes all your workload and gives the result to the server, which is the web application server, where it has to give the result on the website. So basically only processing happens on AWS Lambda. Only website deployment happens on Elastic Beanstalk, right? And AWS gave us these two wonderful services so that we can create a distributed kind of an architecture wherein, there is no fault. If there's a fault in one server, it's not like my whole application will go down. I have certain redundancies in place. I have distributed my work among multiple computer nodes so that even if one gets faulty, it's not like my application will go down. We'll discuss more on this as we move along and we talk about auto scaling. But guys, remember this, AWS Lambda is only used to run your background code. AWS Elastic Beanstalk is only used to deploy a web application. EC2 can be used for anything. It's your own private computer. You can install any software, make it a backend server, make it a web application server, make it a database server for that matter. Do anything with it, right? That is what AWS EC2 is. Now, if you see the diagram over here, as you can see that, let's say there's an e-commerce application, right? And that e-commerce application, there's a trigger for basically buying something. Let's say you order a package, right? So when you order a package, what happens on Amazon? That entry is made into the database. So that entry is stored, let's say, in DynamoDB, which is a kind of database in AWS, right? Now what happens? Now, once the data is stored in DynamoDB, you want to do some processing on that data and then go ahead and store it somewhere else, right? So once the data has been stored in DynamoDB, I need the processing to be done. Now, the one way to do it is you do everything on the same server, where basically let's say my package order confirmation happened on the web application, right? The web application server triggered this particular action that I have my package order is confirmed. And that's when it issued a command to store the data in DynamoDB. That is all done by my web application server. Now I can also, this server itself can also do the processing for DynamoDB and then store it on Redshift warehouse. But the processing takes a lot of time. And that is the reason I differentiate my processing on a different server, or I make my processing happen on a different server so that there is no overhead on my website, so that my website is not becoming slow irrespective of the fact that what kind of workload is running in my backend. Because that workload is being managed by AWS Lambda, right? So my website can be up and running. It will always be available to all the users irrespective of the fact how huge of processing I have to do, right? So that happens by AWS Lambda. One more thing, guys, one more cool thing about AWS Lambda is that whatever job you give to AWS Lambda, it's not one server which does the job. AWS Lambda takes a job, executes it in one server. If it gets one more job in the meanwhile, what it does is it launches a second server on which that job will be executed. Similarly, if there's a third job which is coming, it will be executed on a third AWS Lambda server. So that's how it works, right? And once the processing is done, it can also give the communication back to the web application, and that's how you get the message that the operation is done. But what you don't understand is how many computers or how many servers are working in the backend, right? So now you know. So AWS Lambda, wrapping up, guys. So AWS Lambda is used for executing a backend code. AWS Elastic Beanstalk is used to deploy a web application. And AWS EC2 is a raw server which you can use to make that server anything, right? It could be a web application, it could be a backend server, it could be a database server, etc. Our next service, guys, is load balancing. Now, what is load balancing basically, and why do we need this kind of a service? Now, guys, I told you that whenever we create a production grade application, we basically deal with distributed computing, right? So when we talk about distributed computing, we also have to talk about redundancies so that my application is highly available. Now, what does that mean? Imagine these three servers are your web application servers. Now, if you just had one, imagine you just had one. In that case, what will happen? If there is any kind of fault in this particular server, my application will go down, right? So what I do, I launch 3 exact copies of that server, right? And what happens in that case is, if this server goes down, my user can view my website on this server. If both these servers goes down, my website can be viewed on this particular server, right? But now you might be wondering, how will the user know which server to go on, right? And that is exactly what Elastic Load Balancer is all about. So Elastic Load Balancer, what it gives you is, it will give you one domain to go on, or it will give you one IP address to hit on. You hit that IP address and Elastic Load Balancer will automatically analyze where to send the requests. So the Elastic Load Balancer constantly keeps a check on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy. If there is a server which becomes unhealthy, what your load balancer will do is, it will stop routing traffic to that particular server, right? And it will start routing server to your traffic to other servers. And this is the main job of Elastic Load Balancer, which is to distribute traffic among all the healthy instances which are out there, right? Also, one more important thing over here is, guys, if all the 3 servers are functioning in the healthy state, in what will it do in that case? So it will distribute the data equally among all the servers. Now you might be wondering, how will that help? So let's say I just have one server over here with around 16 GB of RAM and let's say an i5 or an i7 processor, right? So it will be able to serve a limited amount of users. Let's say there are 10 people, right? So who are there on the website. Let's say the server will be able to serve 10 people. Now what happens if there are 20 people tomorrow? In that case, you always have to plan ahead and you have to keep more servers in your group, so that, or in your architecture, so that if there is more traffic, my requests can go on the other servers, so that the load is actually decreased on the first server, right? So what load balancer does is, it will never make one server max out on its performance. It will always distribute the traffic equally among all the servers, so that the processing or the overhead on any server does not go up, and my application should not become slow, right? Now you might be wondering that how do I constantly keep a check on how much traffic is coming on my website and accordingly deploy servers? So that answer I will give you in my next service, which is AWS Autoscaling. So what is AWS Autoscaling? It automatically scales up the number of servers based on how much traffic is coming onto those servers. Now, how does it do that? You can set a certain threshold. Let's say there are 4 instances which are running on my architecture. So what I can teach autoscaling is that whenever the collective CPU usage goes beyond 80%, launch one more instance in the group. And the load balancer should now route the traffic to the new instance as well, right? So this is what autoscaling is. Similarly, when the CPU usage collectively goes below 40%, let's say, decrease the size of my fleet, decrease the size of my server fleet. So in that case, what I'll do is at the moment the collective CPU usage goes below 40%, it will decrease the number of instances in your autoscaling group, right? And that's how it works, guys. And the autoscaling service cannot exist alone. It always has to work in conjunction with AWS load balancer. Why? Because if the size of the fleet is increasing, if the size of the fleet is decreasing, there should be an entity on top of it which will distribute the traffic equally among all the instances, right? So if you are making use of autoscaling, you will always make use of AWS load balancer. On the other hand, you can just make use of AWS load balancer and you might not want to use autoscaling. That is fine. But if you're using autoscaling, you absolutely have to use a load balancer for your traffic routing. All right. So this is what autoscaling is, guys. Our next service is Elastic Container Registry. Now, what is Elastic Container Registry? For this, guys, you have to know what Docker is, right? So if I have to give you a brief about what Docker is basically a tool using which you can launch operating systems in the minimum size possible. So the minimum container size that I know of is 40 MB. So what you can do is, let's say we were talking about distributed computing, right? So in distributed computing, what happens is each of your server plays a different part in your application.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Right? So similarly, what we can do is we can launch containers. Now what containers do is they act as a virtual server, right? But they take the minimum resources possible. They take minimum space possible. Like I said, 40 MB is the size of a container which holds an operating system, right? So in those containers, you can deploy applications, okay? And these applications then run as if they were running on a separate server. They are isolated from the operating system on which the container is running. I'm sorry guys if I cannot go in depth of what Docker is right now because it's altogether a separate topic, but you can understand it like this, that it's basically a mini virtual computer that you can run in your system. And ECR service, basically what it does is it stores these containers in a repository. Like you have GitHub for storing code, you have ECR for storing your container images, right? For example, like I said, operating system 40 MB size, the image has to be stored somewhere, so it will be stored in ECR. Now, if you want to run those images, you have a service called ECS. So what ECS does is it runs any Docker image on the AWS infrastructure, right? And it orchestrates it in a way so that if there is anything wrong with that container service can again be launched. Now don't get confused guys with what we do in EC2. Now you might have a question that I can launch multiple EC2 instances. In spite of that, why don't I launch just multiple containers? Because in that case what will happen is you're still the machine on which the containers are running, that becomes node point of failure. That means if there is anything wrong with that machine, any number of containers which are running on your particular system will go down, right? So this is also a redundancy that you can make in your architecture, that you can also run applications on containers which are running on an auto-scaling infrastructure, that is a machine on which Docker is running. But if the processing or if the CPU gets an overhead and the CPU processing increases, you can scale your machines and you can scale your containers as well, right? So if it's a little complex for you guys, you can just ignore this service, which is ECR and ECS. It's only for those guys who understand what Docker is. So guys, ECR is nothing but it's a repository on which you can store container images, and ECS is nothing but a service to run your Docker containers. If you don't know guys what Docker is, I'll just give you guys a link after this class. It's basically a video for introduction to Docker. It's a half an hour, 45 minutes video. You go through that, and then again you can go through this recording wherein you can find a description for what ECR and ECS is, and that'll make more sense to you in that case. All right. So guys, we have discussed ECR, we have discussed ECS. Alright guys, so moving forward now, let's go ahead and do some hands-on. I think it's enough of theory for compute. Let's go ahead and launch some compute instances in AWS. Alright, so what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat -test, right? We'll click on continue. Then it'll ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give 1 2 3 4 5 6 7 8 9, and the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS guys is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. right? So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS Solutions Architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have Ground Station, Security Hub, Artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. All right. Now, what we wanted to do was we wanted to launch our first server. And for that, there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2. So I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that. And now this link would basically open your EC2 dashboard. Right? So from here, you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service. And that will be in the further sessions that we're going to have. For now, just understand how to launch an EC2 instance. And for that, you just have to click on this blue button, which is here, which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. You have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay. So let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from. Right? But the only server that is free for you would be T2.micro, okay? Which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS, okay? So you would select T2.micro if you want to be under the free tier and not be charged. So just select T2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default, it's 8 GB when you're launching a Linux instance. So we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something. Then the department to which this instance belongs to is there. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches, you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is a message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being launched. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's the software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay, so once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch your Putty software. Right, this is my Putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part, now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH. Then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it'll give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it'll verify the key that I inserted and it'll be able to connect to the putty to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay, so you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this. Right, t2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which is there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right. So let's name this instance as Windows. All right. And now in order to connect to it, this is the IP address that you get. Now just click on actions. So select the machine that you have to connect with. Once it's launched, you would be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect. And this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator. And if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch. But this is the way you get the password. Okay, now if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here. Right. And once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this PEM file will work. So I'll just enter the test Intellipaat.pem. Remember the PEM file will work and not the PPK. Let's click on open. And now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here, and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes. And now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything. Okay. So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard look for Elastic Beanstalk? Right. So as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host an application. So let's give it an application name. Let's say it's test. Okay. And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET. I can put my web app in Go. I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these are all the settings that you had to do, guys. Nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys. You will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. Alright, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kind assist, fire assist, log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares, and then you'll be able to do that job. So I guess, hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Autoscaling and load balancing, we will do it as we move along in the sessions, because that requires you to know a little bit more, right? So let's move on and come back to our PPTs, and let's start with our next domain now. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, it was a file before and now it's an object. Object basically is at the back end, that is how you store a file, is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS, which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that AWS guarantees that your object will have. And obviously you can increase this SLA, this is basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, from the vaults and then store it back again in the bucket.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
But that is only when you have failure in the S3 service, and for that I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket and you will be able to host static websites in that case. Alright, our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS and you feel that you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture, where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next. Leave everything at default, and now let's just click on create bucket. All right, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It'll now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3? You want to archive the data, put it in Glacier? All those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here, right? Now, if I select this file, I can actually see the properties of this file via this link, right? Here's an object URL that you get. If I click on this object URL, it'll say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm. And my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now, if I go to the website, hit refresh, I can see the image over here. Now, this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website, and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS Management Console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step. Right, leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright, guys, so my file system is now being created. Now remember, guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by You can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here to basically connect to these two instances, right? Now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here, and now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is the security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking, you'll go to actions, go to networking and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let's the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay, now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test 2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test 2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we have successfully discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elasticache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It makes sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is, it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB, or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is, under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elasticache. So Amazon Elasticache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server, or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens? Your server is again and again doing a query on the database using a particular query, that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elasticache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elasticache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now, what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay, so each user can have their own user ID and password, but basically they will be logging into the same AWS account, and that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS Management Console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now, what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now, what is an application account? Let's say I have a website which can upload data to S3. Now, how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise, it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means Key Management Service. So Key Management Service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation, then we have AWS OpsWorks, then we have AWS CloudTrail, and in the end we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay, so let's say I have launched two EC2 instances with a load balancer with in an auto-scaling group which is connected to an RDS instance, which in turn is also connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region, I want to replicate it across multiple regions. So in that case also, CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks, and what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say, MySQL on, let's say, 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the OpsWorks architecture. And then in that case, it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes, which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening. And it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it. And then that log data basically you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now what kind of alarm can it trigger? It can either email you, or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay. Moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, we'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services basically, guys. One service is called Simple Notification Service and the other one is Simple Queuing Service. Let's see what these services are. So the first service, which is Amazon Simple Notification Service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay, so based on the topics, the messages are filtered, and what you do is in the topics you will define which service to basically trigger, and based on that those services will be triggered, and the services to be triggered are basically called subscribers. Okay, so guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue or it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay, what it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to that to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So for I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. Alright, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will pay, you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay as you go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. All right. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get for instance is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS, which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS, which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it'll offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this, basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right, so that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS, or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right, so the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you are running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect the service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free. And the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now, as of now, this MySQL database is on the local host, and also the website is on the local host. And right now my website cannot connect to S3 because it is not being being able to authenticate itself. All right. So this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right. So without any ado, guys, let me first show you how my website basically looks like.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So let me jump on to my browser, right? So guys, my website basically exists on localhost/new, right? So this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading, I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my localhost. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. All right, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once a entry is made inside the database. Second thing is, right now if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now how can I give authentication to my website so that I can upload on S3? For that, I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here what I'll do is I will create a user, right? And let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now the kind of services that I want my website to access is only S3, right? So let us put an S3 over here, and as you can see there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user, guys, I will have the access key ID and I will have the secret key, access key. Now this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID, guys, and this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like, guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket. Right, which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website, And as you can see now, it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded, right? Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload, let us not take an image. Let us try to put something else. So let's say there's this app, this test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size, that's why it's not uploading. So what I can do is let me take this particular image, right, and let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on create database, and the type of database that I want is MySQL. Let's select that, and now let's click on next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on next. Right now it'll ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great. Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only the instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay, so but because our website right now is in my local host, from local host I should be able to upload data onto the database of AWS. So for that I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay, what should be the database name? So the database name would be the same. that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on create database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. Right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on create application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take guys 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. Alright, so it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit, right? So this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? And my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry guys, I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket, and this remains the same for each and every object which gets uploaded. Right, so I'm uploading, I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website. Right, so if I can show you over here, as you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right, so once I've done that, it works great. It works like it is supposed to. Now I guess we should go ahead and check if my RDS is ready. Yes guys, so my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my local host. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait. So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for their security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which would be the same as what I did on my local host. So the table name would be names and the field name would be name, and the type of information that can go in is varchar. Let's specify that.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is, let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. Alright, that's it, guys. That's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select star from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great, guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk, guys, and this is the dashboard that I get when I use the platform as a service instance. Right now it says here upload and deploy. So that's what I'm gonna do. I'm gonna click on upload and deploy. And now it's going to ask me to choose a file. Now the way you can upload your website over here, guys, is you will have to go to your website codes, right? And then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay, and now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said, and whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS 1.0. So let's say in the future I make change to my code, any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete, and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if we go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here. And if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my localhost, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that, guys. And it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it. So what I'll be doing is, first of all, let me go ahead and show you how a network like this is possible, where you do not have internet connection in one part of the network and you have internet connection in the other part of the network. Okay. So first of all, you'll have to sign up on AWS. Okay, so let me just quickly log in. And when you have signed up on the cloud, this is how your dashboard is going to look like. This is how your dashboard is going to look like. These are all the different kind of services that AWS offers, and we are going to make use of some today to do what we have to do. All right, great. So now that we are on this management console, the next thing that I'm going to do is I'm going to choose a service. So when you want to deploy any kind of server, if you want a machine from AWS, the kind of service that you have to make use of is called Elastic Cloud Compute, right? So the short form of this is EC2. So you will have to make use of a service called EC2. So EC2, you can choose, you can go to all services under compute, you will find the EC2 service. Just click over there. And this is the management console that you will get. Okay. Now my job is to deploy a server. I will do that. But first I need the network that we were talking about, since the past 15-20 minutes. We need the network ready first where we will be deploying our servers. Okay. So the EC2 service is for deploying your servers. Now for getting a network or deploying a network on cloud, there's again a service, and that service is called VPC, which is called Virtual Private Cloud. So we are going to type in VPC, and you will get isolated cloud resources kind of a service over here. Just click over it. And here you can deploy the kind of network that you want. Okay. So now let me, brief you about what we are going to do. So first of all, whenever you talk about networks, guys, networks, the word network is can be a very big architecture, but networks have subparts to it as well, which are basically called subnets. So if I have let's say your office network, so you guys must be working in offices, you might be in colleges. So your office will have one network. Then in that one network, you will have, let's say, a network for the HR department. You will have a network separate for the developer department. Then you will have a separate network for, let's say, your leadership team. So everyone will have different access to the different part of the network, and every network will have its own access. Okay. So first of all, let's deploy the big network. Let's deploy a network for our whole application, right? And our whole application, I'm not restricting it to say that this whole network will have internet access or not. This is the overall network that we are deploying right now. And inside this network, then we are going to create subparts where we are going to, uh, uh, define the functions that each subpart can have. For example, some parts will have internet access, some parts will not have internet access. So that is something that we are going to do now. Okay. So first, let's go ahead and create a network. For example, let's create a network for your office. So let's call this network as Netflix. Okay. This is where all my resources are going to be. So I am going to name it as Netflix, and let me give, an address. So everything that you deploy on a network has, an IP address. For example, right now, if you're accessing the internet, your computer has an IP address. Why? Because you are connected to a network which is called internet. Similarly, if you are connected to your office network, you also need to have a separate IP address which will make you recognize on that network. Okay. So now what we're going to specify in this IPv4 CIDR block is the range of IP addresses that I'm going to have. That is, let's say if your computer connects to my network, what is the kind of IP address which will be assigned to you? So let's say I specify over here that anyone who's trying to connect to this network will have an IP address which will look something like, let's say this. So this is the range that I'm specifying over here. So here in this range, so your IP address will always begin with 10.1, and then this number will change according to what your network configuration is. So this is the range that I'm specifying over here, and this range is where my application is going to be deployed in. Okay, so let's click on create. And what you have now done is you have created an office network, or you've created a network for your application. Okay. Now inside this network, I'm going to create subparts. Okay, because some resources I want to give internet access, and some resources I do not want to give internet access. So let's see how we can go ahead and specify that. Okay, so I have created a network called Netflix. Now inside this network, let's create some subparts. So for creating the subparts to a network, what you do is you create subnets. Okay, so I'm going to click on subnets. So let's create some subnets for my Netflix network. So I'll click on create subnet. Let's say what I'm creating right now is for a network which is going to have internet access. So let's call all the networks which will have internet access as public, and all the networks which will not have internet access as private. Okay, so let's call this network as public. And when you're deploying servers in AWS, you can deploy it in many data centers. Okay, so right now what we are dealing with is the Oregon region. So Oregon is basically a place in the US where AWS has many data centers. And how many data centers are there? There are almost 4 data centers that you can choose from. So let's create, a public subnet in 2A data center. Okay, and let's call this public subnet as 2A. And this subnet will be deployed obviously inside my main network, which is Netflix. So let me select that, right? And it is going to be deployed in the 2A data center. And let me specify the IP address range, which is going to lie obviously between this particular IP range that I specified earlier. This will be the IP range where I will have, my resources will be assigned the IP address from. Okay, so let me specify it as 10.1.1.0/24. So these numbers that you see /16, they basically denote a range. 20, if I specify something called as /24, that's a smaller part of a range which is /16, right? For example, if I specify, so just assume it like this: if I specify /16, there are going to be around 65,000 IP addresses that I can give using this range. Okay. Now, when I specify something as small as /24, I will have an IP range of around 256 to 256 servers. So I've just created public 2A, which is basically a part of my Netflix network, and it is deployed in the 2A data center, right? Similarly, let me create one more subnetwork. Let me call it as public 2B. This is going to be a part of the 2B data center. It is going to also have internet access. It is going to be a part of my Netflix. What do you say? It will going to be a part of the Netflix network, right? And the range is going to be 10.1.2.0/24. Okay, let's go ahead and create it. Okay, so now what we have done is we have created 2 subparts in the data center 2A and in the data center 2B. Now let's go ahead and create private subnets which are not going to have internet access. So let's create them. So let's call this as private 2A. It's going to be part of my Netflix main network. It's going to be a part of the 2A availability zone. And this is going to basically have this IP range. Okay. Now, similarly, let me create a private 2B as well. /24, and let me go ahead and create it. Okay. So, okay, there's a small change over here that I'll have to do. So once you have deployed it, guys, you can verify if it has been deployed in the correct data center or not. For example, private 2A has been deployed in 2A data center. That is great. But when we talk about public 2B, it has again been deployed in 2A data center itself. So what I can do is I can delete it quickly and I can create public 2B once more. Okay, so let me create public 2B, and VPC is going to be my Netflix network. It's going to be part of my 2B network, and this is going to be 10.1.2.0/24. Okay, so now I have private 2A, I have private 2B, I have public 2A, I have public 2B deployed, and these should be now in the respective data centers. If I've named it 2A, it's in 2A. If I've named it 2B, it's in 2B. If it's in 2B, it's in 2B, and 2A is also there in the 2A data center. Great. So I have my network deployed. Now let me go ahead and define their functions. So what I've decided is my public subnets will have internet access and the private will not have internet access. Okay. So what I'm going to do is first I need internet connection to my network. So how can I give internet connection to my network to these public subnets? Let me go ahead and tell you. So for example, if you need a Wi-Fi at your home, or if you need internet at your home, what do? You contact an internet service provider. They basically bring a modem to your home, and then that modem you connect to your Wi-Fi router, and by connecting to your Wi-Fi, you're able to use your internet, right? Similarly, if I want to give internet to my network, what I'll have to do is first I will have to go ahead and request for something called as a internet gateway. So let me create an internet gateway. Let me call it as Netflix network internet gateway. Let me create it. Okay, so it has been created, and now you'll see it in a list. So I've created the internet gateway. Now I will attach it to my Netflix network. So here you can see, you can find something called as attach to VPC. Let's click over here. Let's select the VPC that we want to connect to, which is Netflix. Let's select it, and let's click on attach internet gateway. Okay, so my internet gateway is now attached to my network. Okay, but still the resources that are going to be in my network, they will not be able to access it. The reason for that is whenever you deploy a resource in a cloud, it is not directly deployed in the main network that you created. It is always deployed in a sub part of the network, which is basically nothing but the subnets that you created. So the subnets that you have deployed, you have to configure them to connect to this internet gateway. Okay, now internet gateway is part of your network, but your subnets are not knowing about that internet network. So uh, in a simpler way, if I were to tell you, you have Wi-Fi at your home, but you are not connected to your Wi-Fi. So your laptop does not know if it can connect to that Wi-Fi or not. Okay, so what I'll be doing now is I will go ahead to something called as route tables. So route tables basically specify which IP addresses can connect to a particular resource in the network and which IP addresses cannot. Okay, so let me go ahead and show you guys how the route table is basically going to be configured. So right now, there is one route table which is automatically created for your Netflix network. Let's call this route table as the internet route table. So whichever subnets or whichever part of the network are going to be connected to this route table will have internet access. And let's create a route table which is called non-internet route table. right? And let's also deploy it in the Netflix network only. So this route table that I have created over here is going to have all the resources which do not have internet access. Okay. So to this non-internet route table, let's go ahead and attach the subnets which will not have internet. And to this internet route table, let's attach the subnets which are going to have internet. Okay. So first let's attach subnets to the internet route table. We'll click on subnet associations. And here, as you can see, there are no subnets attached to it as of now. We'll click on edit subnet associations and we will attach all the public subnets where we need internet to this route table. Okay. So now the route table have been attached. The subnets have been attached to this route table. And now what you will do is you will specify a route to the internet gateway in this route table. And then what will happen is all the subnets which are connected to this route table will be able to see that internet gateway. Or in other words, whichever laptop is at your home will be able to connect to that Wi-Fi. Okay. So let's click on edit routes. Let's click on add a route. And here, let's say everyone in this network should be able to connect. So when you have to say everyone, you give a destination or IP address like this. Okay. So all the IP addresses which are there in this subnet should be able to connect to my internet gateway, which is this, right? And let's click on save routes. So now what have we done? Let's revise. So we connected two subnets to this route table, which basically I named them to be public subnets. And these public subnets, I have given a property to them that they can connect to the internet by using an internet gateway. Okay. So now that we have one network which is going to have internet with us and the other network which is not going to have internet with us. Now what I'll be doing is, so I think I've not connected the subnets to my non-internet route table. Let me go ahead and connect. I'll go to subnet associations of my non-internet and let me connect the private subnets to it. So private 2A and private 2B. Let me connect. Okay. So now I have the two route tables configured and I have my network configured in the fashion that I've just explained to you guys. And now one final setting that we will have to do is we will go to subnets. Now the resources which can talk to each other on the internet or which will basically have internet access, they will need a public IP address as well. If they don't have a public IP, be outside from the Netflix network will not be able to talk to them. Okay, so how do we configure our resources which are being deployed in the public subnet to have a public IP address? This is a small setting that you have to do. So you will be clicking on your public subnet. You will be going to actions. You will have to go to modify auto assign IP settings. Click on enable auto assign public IP for address and click on save. So now all the resources which are going to be deployed in public 2A are going to have a public IP address. Public IP address is basically an address which can be reached out from the internet. Okay. All the 10.1 IP address ranges that I specified earlier are basically going to be a part of the local network, that is the Netflix network. But when we talk about the internet is also a network, right? So internet also has its own IP addresses which are given to people when they want to connect to each other, right? So for example, if I am connected to the internet, if I go ahead and see what is my IP address, this is the IP address that I have, right? And this IP address is basically given to me by my internet service provider. So similarly, if I want to deploy a resource on AWS which is connected to the internet and to which I want to connect to, it should have this public IP address. Okay, so that is what we have configured, that all the resources in my public 2A will have a public IP address, And even in public 2B, I will specify that they can have a public IP address. Okay, great. So now all the resources that I'm going to deploy in public 2A and public 2B will have an IP address. And now we can simply go ahead and go to my service EC2, which we talked about earlier, which is going to rent me servers. I will go to that service.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
And let me deploy some servers now. So what I'll do is I'll click on running instances. And let's click on launch instance. Okay, so the moment you click on launch instance, now let's see what are the kind of options that we see on the screen. So now when you want to rent a server from cloud, the first thing that you need to decide is what is the kind of operating system that you want to run on that server. Okay, so let's say I want to run a Linux server. So let me select Ubuntu. I want to run the Ubuntu operating system on my server. Okay, so I'll select it. And now it will ask me what is the kind of processor, what is the kind of RAM do you want for your server. So here's a list that you can select for. Now, if you want your server to be a part of free tier, you can see this green highlighted text over here, which says free tier eligible. Select that. It will give you 1 core CPU and it will give you 1 GB of RAM. Okay, let's go ahead and click on next. Next thing it will ask you is what network do you want to deploy this resource in. So I want to deploy it in my Netflix network, right? And since this is going to be a public instance that I'm deploying, because first what I want to do is I want to configure my server that I'm deploying on AWS, and later I'll shift it to a private network where we will not be able to access it from the internet. Okay, so I am going to deploy it in the public subnet as of now. And what I'm going to do is rest, I'm going to leave everything at default. I'm going to click on next. Now it will ask me what is the kind of space or what is the hard drive space that I want for my server. So when you deploy a Linux server, it has minimal requirements. So a Linux server with 8 GB of RAM will work, 8 GB of storage space will work. So I'll just click on next again. And now this is the place where people were referring to, will it have any firewalls? So when you talk about firewalls, you basically are referring to security groups in AWS. Okay, so my instance will basically, or my servers will be governed by a firewall, which is called security group. And I can create a firewall or I can choose an existing firewall as well. So when you create a new network, what happens is automatically there's a firewall which is created, which is basically called the default firewall. So it's called the default VPC security group. Okay. If you select that firewall, what are the kind of things that you can configure over here? Let's see. So first of all, what you can configure is the kind of traffic which is allowed in this firewall. Okay. So right now it says all traffic is allowed. Good. What protocol is allowed? All protocols are allowed. Okay, so we'll have to restrict this firewall in a little while. We'll do that. What port range is allowed? Any port from any traffic is allowed. Okay, and who can connect to this firewall? Only the people who are part of this security group can connect. So this we will have to change, since I want to connect to the server to configure it. So I will have to put my IP address over here.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
In the source. We'll do that in a little while. But for now, this is the firewall that you all were referring to, right? And this is something that we are choosing as default over here. You can create it as well. If you create it, you will again get the same options, but you will have to configure them. Okay, so let's click on review and launch. And now you can just review all the settings that you have done. If everything looks good, you can just click on launch. Now, AWS as a security option, it does not give you a simple password-based authentication to your server. What it gives you is a file which you can use to connect to your server. Okay, so that file is basically called a private key file, which you will have to download from over here, right? So I have a file that I already created. It's called Mac Oregon. So I'm going to select that. I already have it on my system. If you don't have it, you're creating it for the first time, you will have to choose create a new key pair. Let me create it since we are doing it over here. Let's specify as Netflix demo. This is the file that I will be using to authenticate to my servers. Once you specify the name, just click on download key pair. This will be downloaded to your system, and then later you can use it to connect to your server. Okay. Now I click on launch instances. And with this, my server has now just been launched. Okay. And I've launched it inside a public subnet. Okay. So now I've just launched a server, right? And this server is now a part of my public subnet, which means this has internet access. So let's see what all things we have available for this server. So let's call this as Ubuntu server. Okay, so this has a public IP address. Great, I can use this IP address to connect to this server, right? It has the private IP. Private IP is basically the IP which is given inside the network. So as you can see, the range is 10.1, which is exactly what we specified, right? It is a part of the 2A data center, which is good. The firewall attached to it is default. So we will have to change the default rules for this firewall. And others you can verify whatever you configured, exactly those configurations you can see for your server over here. Okay. Now what I'll be doing is I will be selecting the security group, which is the default security group. And let me change the settings over here. So first of all, I'll be changing the inbound rules. So the inbound rules of my firewall right now are these. So let me change this. So I click on edit inbound rules. And now, first of all, let me tell the server that only I can connect to it. So I will specify my IP. And as you can see, this is my IP address that has been specified. So only my system will be able to connect to this server. And right now you can see this is the public IP that has been attached to my firewall. Okay. So any kind of traffic from my IP address will be allowed to this server. Okay. So this is the setting that I'm specifying right now. I'll click on save rules. And this setting is done. Now, this will be changed later when we will be deploying our full stack application. But for now, this is the IP range that I have specified. Okay. Now I'll go back to my dashboard, go back to my server, select the server that I want to connect to. So this is the Ubuntu server. So you will notice I have some other servers, EC2 demo, which have been created over here. So this account is used by a lot of people. So you don't have to worry about the other servers which are being launched. Just select the server that you want to use. So in my case, it's Ubuntu. Now I'll be connecting to it. Okay. So this is the IP address that I'll be connecting from. Let's copy it. And now to connect to it, I will make use of my terminal. Okay. Now here is something that will be different, that can be different on your system. What is different on mine? So I am using a Mac operating system. So I have something called as a terminal, right? So this is a bash terminal that I'm going to use to connect to my server. Okay. Now, when you might be on a you might be on a Windows system. So in that case, if you want to connect to your server, you will have to basically make use of a software called Putty. Okay. So there's a software called Putty, which will basically make you to connect to your server, right? So what we basically make use of is the SSH protocol to connect to a Linux server. So this tool, the Putty tool, will help you connect to your server using the SSH protocol. So just click on the first link that you see. You can see it says you can download Putty over here. Just click over it. And here you can download, the Putty version. So you have to download the 64-bit version. In case your processor is 64-bit, if you have 32-bit architecture, then you will be selecting the 32-bit version. Okay. Once you download it, there is one more software that you have to download, and that is called Putty Gen. Okay. Download this as well on your system. Now, once you have Putty Gen and Putty downloaded, what you have to do is, you remember the key pair file that you got? This is the PEM file. This is the key pair that you got, and this is only for Windows system that I'm telling you right now, guys. So this PEM file is not compatible with your Putty software. Okay. So what you have to do is you have to convert this PEM file into PPK, and that can be done using this PuttyGen software that you will be downloading. Okay. So how you can use the PuttyGen software? Let me show you some screenshots. So this is how your software is going to look like. You don't have to enter any values in key comment key phrase. So what I'll do is, okay. So this is how your Putty Gen will look like when you open it for the first time. So what you have to do is you have to click on load. Okay, it will open a dialog box. Select the PEM file that you downloaded. Click on OK, and then click on Save Private Key. Okay, what this will do is it will save a PPK format file on your system, and that is basically the file which you will be using now to connect to your server, right? So PEM files are compatible with Linux systems, but PEM files are not compatible with Windows systems when you're using the Putty software. So you have to convert it to PPK. Okay. So with that done, once you have the PPK file, next you will be opening your uh, Putty software. So your Putty software will look something like this. Okay, this is the UI that you will get. So the IP address of your server will go over here in hostname. So this is my Ubuntu server. This IP address will go over here in this dialog box, the hostname. Okay. So once you put the IP address over here, next what you have to do is you have to click on SSH, right? And once you open SSH, you will find something called as auth under it. Click on auth, and then you will get a browse window over here. Okay. So if you click on SSH, you will click on auth, you will get a browse button over here. Click on this browse button, select the PPK file that you downloaded earlier, and then all you have to do is click on open. That's it. So once you click on open, you and I will be on the same user interface as what I'm going to show you as of now. Okay. So this is the only difference that is going to be there while I am doing this demo and while you will be doing this demo. So first step, you have to convert PEM to PPK using the PuttyGen software. Put the PPK file over here in browse section of SSH auth, and then put the IP address over here by going to session, click on session, put the IP address over here, and finally click on open, right? So now a terminal will open just like this, and then I'll tell you what has to be done from there. Okay, so now what I'll be doing is, let me pass in the command. So this is the command that you will be using when you're on Linux. Okay, so people who are there on Linux, first you have to go to the folder uh, which will basically have your PEM file, then pass in this command. So ssh-i basically means the server that you want to connect to. the PEM file that you want to connect to. This is the PEM file that I'll be using to connect. And then now people on Putty, you will see a dialog box which will ask you for login as. It'll ask you for username. So if you have launched a Linux machine which has Ubuntu operating system, the username would be Ubuntu. Okay, Ubuntu at the rate. Now when you just have to specify Ubuntu, hit enter, you will be logged in. People on Linux, you have to specify username at the rate of IP address of your server and then hit enter. Okay, so it'll ask you whether you trust the server. This will also be the same for people who are going to work on Windows. You have to type on yes, hit enter, and Windows people will be able to connect then and there to the server. People on Linux will find this kind of a warning which will say unprotected private key file. Okay, so you will have to pass in a command sudo chmod 500, which are basically going to change the permissions of your file, right? And then just change it with 500, and this should do the trick. Now pass in the same command, and there you go. I have connected to my Ubuntu server on AWS. So people who will be doing it on Windows, you will also see the screen as you are seeing right now on my screen, right? And this is how you connect to a server which is deployed on AWS. Okay. Now that we have connected to our server, what I'll do is I will basically make it a web server. And then once our website is ready, we will deploy it in my private subnet, which is not going to have any internet access. Okay. So when you want to create a web server, first thing that you have to do is anything that you want to install on a Linux machine, first you update that machine. Okay, so I'll just type in sudo apt get update. It'll take like a minute to update the machine, or even less than a minute. So it took 10 seconds to update the machine. Now what I'll be doing is, so this is the command that I passed to update the machine, sudo apt get update. Next thing that I'll be doing is I will be installing a web server. So sudo apt get install Apache 2. So this is a web server which is now getting installed. Okay, so I just choose yes. Okay, so web server is now being installed. And after this, we'll do a very cool exercise, guys. So you will be able to see that if I go to the IP address of my server now, so I just type the IP address over here in the browser. You can see I can able to access this page in my browser. Okay. Okay. So now what I'm gonna do is, guys, I'm gonna basically go ahead and define a web page over here. So let me show you how we are going to go ahead and define our web pages. Okay, so what I'm going to do is this is the architecture that we are going to deploy now. So I will have a separate web page for streaming servers. 1 second. So I will have a separate web page for my video page, and I will have a separate web page for my home page. Now let me show you why we are going to do like this. So let me go ahead and open the website called netflix.com and just see what is the behavior. So if I go to netflix.com, I automatically go ahead and get routed to netflix.com/browse. Okay. And if I select the account that I want to use, it's still the URL over here. It's netflix.com/browse. So netflix.com/browse is taking me to the homepage of Netflix. I hope everybody is clear here. Okay, now what happens if I play a video? Okay, so let me play this series over here. So now what you can see is the URL changed to netflix.com/watch, and then you have some numbers over here, which probably would be the numbers for your video. Okay, so you have connected to netflix.com/watch. One second. You have connected to netflix.com/watch in order to get to this page where playing this video. Okay, now let me show you what happens when you play some other video. So I'll again click on back. Let me play some other video. So let me play, let's say, this Space Force. Can you still see? It's still netflix.com/watch, and then you have these numbers which are after this URL. So these numbers basically are referring to the video which is playing on this page, but this page is same all the time. The page is always netflix.com/watch, which is basically referring you to this video player. And then to this video player, what you're doing is you're providing this number, which is basically now going to play the video that you are launching over here. Let's see if we remove the track ID, what happens. Okay, so this is the number which is associated to the video that you are playing, right? And this is the page that you're going to. You're always going to netflix.com/watch. So if you go to netflix.com/watch, you open the video player, and to that video player you tell, okay, so this is the video that I want to play, and that is what is being played over here. So let's see if I just type in watch, what happens. Okay, you can see they have routed me to something else because they do not want me to just access the web the video player. So when I go to netflix.com/watch, they basically reroute me to some other URL. But you now understand the working of Netflix. What they do is, if you go to netflix.com/browse, they are routing you to the home page. And if you go to netflix.com/watch, and some video ID if you specify, it will take you to that video which is being played. Okay, so now let's see how we can mimic this architecture on our system. So what I'm going to do is, if I go to netflix.com/home, I will be taken to the home page. And if I go to netflix.com/stream, or let's make it watch. So if netflix.com/watch, if I go to, it will take me to the video player. Okay, so this is something that we are going to configure now, and this we are going to do using the AWS infrastructure. Okay, so first of all, let's create a home page. Let's create a page that we will be routed to if you go to /home. Okay, so what I'm going to do is, this is my web server where I'm able to go and see this page. Let's change this page to look like a home page. So what I'll do is, so once you have an Apache 2 server which is running, you can go ahead in this path /var/www/html, and this will have a page called index.html. Okay, so this index.html page, if you change this, your HTML will change over here. Okay, so for now, let me first delete this index.html page, and now let's create a new index.html page. which says, let's say, welcome to homepage. So I will create an HTML page, which will, this is a very simple HTML code that I'm writing over here, which will say is welcome to the homepage. Okay, so this is what I've created. And if I refresh over here, you can see it says welcome to the homepage. And even you guys, if you refresh, you will be able to see this particular web page which says welcome to the homepage. Now our web page, our web server, our homepage is now ready. And now what I'll be doing is I'll be deploying this inside a private subnet. So let's see how we can do that. So for doing this, I will first go to my dashboard. And this is the server that I created. So let me create a copy of this server first. And then that copy, I will deploy it in the private subnet that we created earlier. So I'll just select the server that I created, click on actions. Then you have something called as image. So let's create an image. Image is nothing but it creates a copy of your server which can be deployed multiple times then. So we'll create an image. Let's call this image name as homepage, home, Netflix-home. Let's specify this. Right? Let's click on create image. And now my image is getting created. Okay, and that image will basically have this web server already deployed. Great. So now that it is happening, I think it will take a minute or two to create that image, and you can see that image in the under the image section in AMIS. So if you go to AMIS, you can see that a Netflix home image is being created, and it is in the pending state as of now. So I think if we refresh it a couple of times, you can see it will change to available. So let's wait. So while this is happening, let me explain you how the other things are going to work out. So as you must have noticed, right? So if you want to have a home page which is going to be separate, and if you want to have a watch page which is going to be separate, you will be dealing with two servers, right? And if you're dealing with two servers, you obviously will have two IP addresses, right? But as you can see from the behavior of the Netflix website, the URL always remains the same, right? Only the web page is changing. So how do we accomplish that? So we can accomplish it by having a common medium in the middle, which can connect to both my watch page and my home page. Okay, so this resource, which is the elastic load balancer that we're going to deploy in a minute, is going to have a URL which is always going to be the same. And this load balancer we can configure to understand if the URL is /watch or /stream, it is always going to route my request to the streaming servers. Whereas if my request is /home, or let's say just / or just no URL at all, in that case it will be routing my request to the home page. So this is possible using the elastic load balancer, right? And this is something that we are going to go ahead and deploy now. Now I think we are ready to now understand how our architecture is going to be deployed. So now what I'm going to do is all my servers, they are going to be a part of my private subnet where I do not have internet access, right? But as we have known from the previous from our previous understanding, we know that everything within our Netflix network will be able to interact with each other. Okay, So in my Netflix network, I have a public subnet, I have a private subnet. So private subnet does not have internet access. Public subnet has internet access. So in my public subnet, I'm going to deploy my load balancer, right? In my private subnet, I'm going to deploy all my servers, right? And these servers can only be accessed by the load balancer and nothing else. Okay, nobody else will be able to connect to these servers directly. Only through my load balancer, they will be able to access my servers. And this is a very good architectural practice when we talk about having security for our servers. Why? Because you can control which protocols can you interact with in your load balancer. For example, let's say a hacker wants to go ahead and make use of servers. They want to pass some commands as I did on this terminal. Okay, so if you want your load balancer to restrict that, your load balancer will only allow HTTP traffic. What is HTTP traffic? HTTP traffic is the traffic that you get from your web browser. So only the web browser's traffic will be enabled through your load balancer. If somebody is trying to pass some command, if somebody is trying to connect through some other protocol, it will not be allowed. Okay. And even in that case, your load balancer will only allow some URLs. So only if you type in /home, you will be allowed. If you are typing something else, you will not be routed to my server. That again is a very good security aspect, that if your URL is pointing to netflix.com/home, only then you will be reaching my home server to access that content. You cannot access my content and from any other medium from that particular server. Okay, so this is how you can restrict hackers or restrict attackers from accessing your server, and it's a very good architectural practice to have your architectures deployed like this. Okay, as I said earlier, we are inside one network, and the Netflix network that we created, right? That is the big network that we created. Inside that big network, we created small networks, which were public and private. Public had internet access, private did not have internet access. Okay. So all these resources which are a part of the big network, which is Netflix, all the resources can talk to each other. Now imagine this rectangle is my private subnet. Okay. And this rectangle is my public subnet. And what is the difference that I told you between the two is the public subnet has internet access. The private subnet, it does not have internet access. Okay. So if I connect to a server which is there in my public subnet, right? Because I'll be able to connect to it. Why? Because it has internet access. If I connect to a server in the public subnet, I can then connect my private server through this public server, right? If I connect to this Ubuntu server on my terminal like this,
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
and then in this server which is there in the public subnet, if I enter the SSH command again and I enter the IP address this time, the private IP address of the private server which is deployed in the private subnet, will I be not be able to connect to it? Okay, if I have a private machine which is deployed in this private subnet, if I have to connect it from my machine, what I'll be doing is I'll be launching a machine in the public subnet, and through that I will be connecting to it. So coming back, now we have our homepage image ready, right? Now let's create an image for our streaming server as well. So what I'll do is, again, let's create one more image from this server itself. Let's again go back to this directory. Let's change the index.html And this time, let's say welcome to the streaming page. Save it. Okay. And now, if you go to this IP address, you will see it will now say welcome to the streaming page. Okay. And now let's create an image out of this as well. So again, we'll go to EC2. So in our Ubuntu image, we'll go to image, we'll go to create image, and let's call this image name as Netflix stream. Okay, so now the image will be created for that as well. Now what I'll do is I will go ahead and launch my home page in my private subnet. Let's see how we can do that. So I'll click on launch instance and I will choose my AMIs over here. I'll not choose any operating system now. I'll just choose my AMIs. And now I will choose the Netflix home image, which I created earlier. Let's select it. I want to launch it in the free tier server. Everything is going to be the same that we did earlier. Just that now I will be selecting a private subnet, which I'll be deploying it in. So I'll be choosing the private 2A network. Let's deploy it over here. And this is our home page that we're deploying. Security group, we will select again the default security group. And we're going to restrict it. Don't worry about that. We're going to restrict that security group. And let's choose the same key pair that we used earlier, Netflix demo. Acknowledge that we have it and click on launch instances. So this is now getting launched in US West 2A. It's going to be launched in the 2A data center. This is basically now called Netflix-home. This is the home server that you have launched, home page that you have launched, and it will take a little while. And as you can see, it is now running. Now, if you have a look at the settings of this server, you will see that it will not have a public IP address, right? Why? Because we deployed it inside a private network, right? But it will have a private IP address. But this private IP address can only be reached out within the network. It cannot be reached out from outside of the network. Remember this, okay? So this is the IP address that we will be connecting through from our public instance, which is nothing but this instance that we connected to earlier. All right. Okay. So we have launched our home page. Now let's go back. Let's see if our streaming page is ready. So even streaming page is now ready. Let's launch this as well. So I'll just select the streaming image, click on action, click on launch. This is another way of launching it, right? This is the server that I want to launch. I want to launch it under the free tier. It will be deployed in the Netflix network. And this time I'm going to deploy it in private 2B data center. Okay. Everything else going to be the same. Security group, I'll select the default one. Click on review and launch it. Select the same key pair that I selected earlier, acknowledge that I have it, click on launch instances. And with this, my streaming page has also been launched. Okay, great. So now I have two servers which are now deployed inside private subnets. And as you can see, I do not have a public IP address over here. Okay, and hence I will not be able to access them from the internet. These are not having any internet access, and I will prove it to you in a little while. Okay, so I have the home page which is now running. I have the stream page which is now running. I have, let's name it as proxy server. So I have a proxy server which is running in the public subnet, which has internet. Now what I'll do is, using this proxy server, I will be connecting to this home page and the stream page server. So let's see how we can do that. So first we need to copy the PEM file that we have on this proxy server. So let's copy it. So the way you can copy it is, use a command called SCP, which is called secure copy. So first you will have to authenticate yourself using, the proxy server's PEM file. Then you will have to specify the file that you want to copy. So the file name is again this PEM file I want to copy, right? Where do I want to copy it? I want to copy it on the proxy server, which is this IP address. And I want to copy it in this particular file location, which is /home/ubuntu. Hit enter. Since I specified sudo, it is asking me for my computer's password. Specified that. And now the file has been copied successfully. So now if I SSH into my server again, you can see that the file has been copied, netflix-demo.pem. It has been copied onto my proxy server or my public server that I launched earlier. Okay. Now people on Windows, if you want to do the same, what you can do is follow a simpler method. You can download a software called FileZilla. Okay. So FileZilla helps you to copy files from your local system to your specified server, right? The next thing that I will be doing is I'll be connecting to my private server. Now, where is my private server? My private server is this. Let's connect to a Netflix home server. Okay. So Netflix home server, this is the IP address, the private IP address for my Netflix home server. Let's try to connect to it. So I will be typing in SSH-I and then the PEM file, the username, and then the private IP address. So as you can see, earlier my IP was 10.1.1216. Now it has changed to 10.1.3.193. And that is the IP address of my Netflix home server. As you can see, the private IP address of my Netflix home server is 10.1.3.193. So this basically means I have successfully connected to my private instance. Now, for some of you who still have a doubt whether, if I pass this on my local machine, what will happen? So right now I'm inside the AWS server, right? But let's say, this is the terminal for my local machine. If I pass the same command over here, okay, first let me go to the folder which has the pen file. Okay, so if I pass in the same command over here, you will be able to see it will not recognize what this address is. Can you see it's not connecting? It's not doing anything. Why? Because it does not know what this IP address means. Why? Because my local machine is not a part of the Netflix network, which is there on AWS, right? But this machine is, and that's why when I passed this command, it was able to connect to this Netflix home server. Now, what I'll do is I'll just check if the web server is running. Yes, so it is active, it is running. That means if I curl, so this is something that I'm just doing for my checking, guys. If you don't understand, it's fine. Okay, so that means my Apache server is working on Netflix home, which is great. So let me just exit. So I've exited, and now I'm back to my public server. You can see the the IP address changed. And now let me log into my Netflix streaming server as well. So I'll just change this IP address to my stream server. So my Netflix stream server has the IP address as 4.167. Let's specify that. So as you can see, I have connected to my Netflix stream server now. And if we check if the web server is running over here, yes, it is running over here as well. Great. So both my servers are running fine, and I've just showed you how to if some maintenance is required, how to do maintenance on your uh, private machines. Right now, what I can do is once maintenance is done, I can just delete this proxy server, and then I'll not be giving any access to my uh, private machines. One thing that I forgot to show you was, uh, let's say this is my public machine that I've launched on right now, right? This is my proxy machine that I've connected to, right? This has internet connection. How do we know that? First of all, we are able to access it from my local machine. At the same time, if I type in curl google.com,
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
you can see that there is a response that I get, right? But if I, let's say, go to my private machine, right? And if I do a curl google.com over here, you can see that I'm not getting any response over here. Why? Because this machine does not have internet access. Okay, and this proves that. Great. Let me exit. And now that our web servers are ready, they are ready inside, a private subnet. Let's configure our load balancers to connect to this machine. Let's create a load balancer. So I'll just scroll on my EC2 console, and I will be able to see something called as load balancers over here. Let's click over it. So let's click on create a load balancer, and I will be creating an application load balancer. So application load balancer basically works on the application layer, and it basically helps us to do path-based routing, that which is something that we are trying to accomplish, which is if I go to netflix.com/stream, I should be going to my stream server. If I go to /home, I should be going to my home server. So we'll be creating an application load balancer. Let's name it as Netflix-demo. This is going to be an internet facing load balancer, right? And the protocol that we are going to use is HTTP protocol. Okay, so here, as you can see, this is very important. So the only protocol that this load balancer is going to allow is HTTP protocol, nothing else. All right. Which VPC will this load balancer be a part of? It will be a part of the Netflix VPC, and this has to connect to 2A and 2B servers, private servers. So if they have to connect to private servers in 2A and 2B, this load balancer has to be deployed in public 2A and public 2B. Only then it will be part of the network, and then it will be able to connect to your machines. Okay, so what is the configuration that we did here? So you have configured your load balancer to connect to your private machines only using the HTTP protocol, nothing else. Okay, let's configure the firewall for this. So firewall, we'll be using the default firewall only, will not be making any changes. Let's specify routing now. So for routing, you will have to specify which servers to connect to, right? So right now, let's go ahead and specify a target group. Let's name it as public-server. And now let's go ahead and specify the public server IP address. So the way I can do that is by specifying the the servers that I'll be able to connect to, right? So what I'll do is target group is nothing but the set of servers that you can connect to, right? So let's specify the name of this to be, let's say this is the home page server, right? Let's click on next. And now what I can do is I can select the home page that I want to connect to. So this is the home page that I want to connect to. and let's click on next again. So this is the target group that I've just created for my home server. I'll be creating one more target group. Don't worry about that. So let me first create it and then I'll explain you what I've just done. So let's create this load balancer now. Okay, so load balancer is now created. Next thing that we will be doing is we will be creating one more target group. So we have created one target group for homepage server. Let's create one for streaming server. Okay, this streaming server will also be a part of the Netflix VPC. And now let's go ahead and click on create. Okay, so now my target group has been created. So I have a homepage server and now I have a streaming server as well that I would want to connect to. And in this, so homepage server should have the homepage server connected to it. So it is not connected. Let's connect the homepage server over here, which is Netflix home server. Let's register it to this target group, save it. And similarly, in my streaming server target group, let's connect our stream server, register it, and click on save. Okay, so both of these now have the targets attached to them. And now what we can do is, now we will be specifying the rules for our load balancer. So let's go back to our load balancer. And now what I can do is, so now I have to specify this routing rule, which is if I go to /stream, then it should connect to the target group of my streaming server. And if I go to /home, it should connect to the servers of my home server, the server of my home page. Okay, so let's see how we can configure that. Okay, so you will have to go to listener and then you will have to specify rules. So let's go ahead and edit these rules over here. Okay, so right now what is happening is anything which is going to this server, it will be routed to the home page server. Okay, so let's add a route over here. Let's click on insert rule and add a condition. So we'll be adding a condition for a path, and the path will be if it goes to /stream or let's say /watch, right? It should then forward this request to the streaming server. All right. So if the path is /watch, the request will be forwarded to the streaming server. Okay. If there is no path specified, it will be routed to my homepage server. If there is, let me specify one more thing. So let me first save it, right? And let us add one more rule. So if the path is /home, okay, let's try and see if this works for us. So if I'm going to /watch, yes. So the star was missing over here. So now if I'm going to my load balancer /watch, I'm going to the streaming page. And similarly, what I'll also have to do is, let me exit and let me go to my home server as well. Okay, so here as well, I will have to add a home directory. Let me quickly do that. Okay, and now if I go to my load balancer, let's say I'm going to /home, you can see I'm being routed to the welcome to the home page. And if I'm just going to the URL, then also I'm being routed to welcome to the home page. Okay, so now what we'll be doing is, now we will be connecting a custom URL to our load balancer. And so first things first, what you need is a URL first. So what you need to do is just go to your Freenom website. So there's a website called Freenom. It basically gives you free URLs. Okay. So just sign up on Freenom. Okay, I'm connected. Let's go to my domains. So right now I have some domains, but I'll be showing you once you sign up, how you can create your own domain. So what I'll be doing is, as you can see, these are some domains that I have. I'll be creating a new domain, just like you guys would be doing when you sign up. So I'll just go to register a new domain, go to services, go to register a new domain. And in register a new domain, just specify the name of the domain that you want. So in my case, I want Netflix-demo. Let's check the availability. So as you can see, these are all domains which are free and I can get them. So let's get this domain, check it out, continue. And just agree to the conditions and click on complete order. So with this, your order has been confirmed and you can now go ahead to my domains. You have the Netflix demo domain registered to you. You can just click on manage domain. And here you will have to go to click on management tools and then click on name servers. Okay, and what you have to type in is custom name servers. So these are some name servers that you have to fill in. Now, how can you fill these name servers? Again, go back to your AWS Management Console. Click on services, type in Route 53. Now, once you're inside Route 53, you will have to choose a hosted zone. Let's click on create hosted zone. And over here, just type in the domain name that you created. So it's Netflix-demo.pk. Give the same name over here. Click on create. And this will create a hosted zone for you. Now, as you can see, these are name servers that you will have to enter over there in Freenom. Okay, so just select this, copy these name servers one by one. Go to the second name server, again copy it from here. Third name server, again copy it from here. Fourth name server, again copy it from here. Okay, so that's all the changes that you have to do on Freenom. You can close it now. Now in Route 53, you just have to do one small change. Click on Create Record Set, right? And now what you'll be doing is you'll be pointing. So what have you done so far? You have mentioned these name servers in your Freenom website, right? So now your domain will be pointing to these name servers, which are basically the Route 53 service that you have. Now this Route 53, you will have to point to your load balancer. So how will you do that? You will find this section called alias, click on yes. And here you have to select your Netflix demo load balancer. Okay, click on create. So entry is made over here. Similarly, one more entry you have to create with the similar settings, just that in name you will have to enter www as well. Click on alias yes, select the load balancer, click on create. Okay, so with this, now your Route 53 is ready. And now what you can do is just go to a browser, type in netflix-demo.tk, hit enter, and it will now route you to the home page directly. And now if you go to the URL/watch, it is now pointing you to the streaming page. And this is exactly what is happening on your Netflix website as well. So let me quickly show it to you. Okay, so if we go to netflix.com/browse, it will take you to the home page. If you type in netflix.tk/home, it will take you to the home page. If you type in netflix.com/watch and then the video title, it will take you to the video player, which will play the video file for you. And similarly, if here you go to netflix.com/watch, you will be taken to the streaming page. And guys, this is how you mimic the architecture for Netflix on AWS. Now we discussed all the jobs which are there in cloud. If you want to become a full stack, if you want to implement cloud in your job, I just showed you some profiles which you can get certified in. Now some of my viewers today would be wondering, like, the current job that I am in right now, can I implement cloud in that? So let me show you some stats. So guys, the top 15 tech jobs which have the cloud related skills in the job description, that is what we are going to discuss right now. So guys, a software engineer, if you go by the generic job descriptions that we see every day, more and more software engineer job descriptions are expecting the software engineers to know cloud, which basically means if you are a software engineer right now and you are aiming for the future and you still want to be a software engineer, then almost 8 to 9% currently job description expects you to 8 to 9% of your job description. That means, let's say you have 100 skills, out of those 10 skills should be in cloud, right? So this is what the 7.92 number means. Then you have the senior software engineer profile, which basically again expects you to have around 6.7% skills in cloud. Software architect expects you to have 6.21%. So basically the aim is to show you guys that all the profiles that you see over here, although they do not coincide with any cloud profile, still they have some elements of cloud skills in their job description, which basically means most of the companies which are related to IT today are doing something or the other thing on cloud, and that's why they expect all their employees to know cloud, right? So what I'm trying to tell you from this slide is, whatever profile you are in, if you want to be relevant to the industry, you should know or you should start upgrading yourself with cloud today. Okay, then these are some of the other profiles that you can have a look at. For example, a cloud engineer profile, a generic cloud engineer profile, a data engineer profile, a Java developer profile, system engineer, data scientist, then a system administrator, Java developer, .NET, front-end developer, back-end developer. All of these people, they have some element of cloud skills in the job description, and that is what you should aim for. If you are currently sitting in these profiles and you don't have this cloud skill, you should get started today. top AWS questions that can be asked to you in your next AWS interview. So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You are basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity. Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now you can think of it as, say you want a deep learning AMI, or you want a Windows Server AMI which specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS Marketplace. So the answer for this is AWS Marketplace. It's basically a place where you can buy all the AWS systems that you, or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D you will not even consider, reason being that you're talking about the log of the client information, right? what all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question, the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer, reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about about architectures which are performance driven, right? So let's take a look at the first question. So the first question says, you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. Alright, so the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want to basically we want to track user data, right? So SNS would not be the apt choice for it, because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice, because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time. right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are auto-scaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances in one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones and we could deploy 2 servers in each and this would also amount to high availability. All right, and of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right, so the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use Elasticache and in what cases? All right. So the answer for this is basically related to the nature of the service of Elasticache. So Elasticache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about a database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an Elasticache, that data can be captured or can be cached inside Elasticache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from Elasticache, and that is the exact use of Elasticache, right? So you use Elasticache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an Elasticache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the requester page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. All right. So I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Requester pays option to access via AWS billing. Again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would we do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you are using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS. So there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS Management Console? So this is a simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are two types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite, that is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? Alright, so to rephrase this question, basically you have an application which has two kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the task should be completed in say 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the backend, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that your database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. Alright. Our next question is, which component of AWS Global Infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible. And it is possible using AWS edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
That's it from our side, guys. If you have any questions regarding this, put them in the comment section below. Thanks for watching and stay tuned for more from Intellipaat.